to the Chemistry Department Faculty of Science and Data Analytics, Institut Teknologi 10 November, Surabaya. The Chemistry Department of ITS has plenty building facilities for students to use. For instance, classrooms with capacity of 40 to 50%, each with LCD projector, AC, and Wi-Fi. Trial rooms for final project presentation and thesis. And discussion space at the corridor. The chemistry office for administration is placed on the second floor. There is a waiting room, office area, discussion room for lecturer, lecturer rooms, and prayer room. There is also a small library on the fourth floor. Due to the pandemic, during this past year, most learning has been conducted online, generally via Zoom. ITS has Moodle-based learning platform called My ITS Classroom. In My ITS Classroom, students and lecturers can find out which courses could be taken in a particular semester. There are also several activities that can be carried out. For instance, uploading files, both lecture files and videos, managing face-to-face meetings, doing assignments, arranging exams. There are 6 laboratories consisting of 1 educational laboratory at the Fundamental Chemistry Laboratory and 5 research laboratories that can support the students' research and learning activities. The other 5 laboratories, the research laboratories, consisting of the Instrumental and Chemical Analysis Method Laboratory, the Microbiochemistry Laboratory,
1973, with General Importer as core of its business, PT Fajar Mas Murni has marked the beginning of its glorious journey. In its first office in Menara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to four business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Mas Murni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Mas Murni is providing the first-rate after-sales service in its field of business. All aligned with PT Fajar Mas Murni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
Okay, so our event is going to be starting soon, so may I have your attention, please? Before starting the event, let us give a warm welcome once again to the honorable guests, our first Vice Rector for Academic and Student Affairs of ITS, Professor Nurul Widya Astuti, and then our keynote speaker, we have Professor Yen Haeng, Professor Shigeru Kada, and Professor Mark Buntin, and also Professor Fahimah Martak in the room right now, and our all invited speakers as well. And other rectorate and other bodies that has come to this event today. Good morning, ladies and gentlemen. Welcome to the second day plenary sessions of the 6th International Seminar on Chemistry 2024. In this morning event, I, once again, Haikal, will be the master of ceremony. We hope that all of the participants and all the people here enjoyed the first day of the conferences yesterday and ready to experience the second one today, because I will show there will be no difference. There are going to be a lot more connection and experience made by all of the people here. There are no opening remarks for today, so today we will going to continue and going to jump on to the two keynote sessions that we have. These two keynote sessions will going to be bring by our two amazing speakers. And after the plenary sessions end, we're going to continue to the parallel sessions. After parallel sessions, we have going to have lunch and then continue again our parallel sessions. And we're going to gather once again in this room to have a closing ceremony. Without further ado, I think I'm just going to give the time to present the keynote session itself. So these keynote sessions is going to be moderated by the most lovable person I could know. He is so loved by the students here in ITS, I could say. Mr. Hendrayanto Sulistyo Putra. Give an applause to him.
Okay, thank you so much for the, I don't know, I mean, Haikal said that I'm lovable. Yes. Okay, I take that as a compliment. Yes, thank you. Thank you so much. So we're going to take the prize. Thank you so much, Mark. So I'm kind of shy because of that. So, but thank you. So we have two really distinguished speakers this morning. So I'm going to moderating those two. First one was Professor Mark. I was asking him, hopefully I'm not saying it wrong, Buntine. Is it? Okay, yeah, Prof. Mark Buntine. So and Professor Fahimah Marta. So Mark is actually working in Curtin University, and then he's also as a John Curtin Distinguished Professor. And I asked him if I don't read all of this, because as you can see, there's so many more publication, and I cannot tell you how great he is, but we will hear about his presentation and his research not long after this. And after Mark's presentation, then we will have probably around 20 minutes of questions and answer. Then after that, we're going to hear the presentation from Professor Fahimah Marta, which is a professor in inorganic chemistry, and she's from ITS. From the bachelor's from ITS, and she graduated her master's and her PhD from ITB in Bandung. and she's working with. What is you working with? The coordination chemicals. Yeah, but we will hear what she wants to present today, and we will ask questions according to her presentation as well. So without much further ado, so can we start the first presentation, Mark? Okay, so I think your time is about 30 minutes, or probably more. Okay. 40 minutes. Thank you, Haikal. So, yeah, we'll wave our hands to you if it's too long. Thank you, Professor Mark Buntine.
So I have to begin by thanking the entire organising team for inviting me to this conference, for looking after me before and during the conference. Everyone has been so wonderful. And I also have to say, in yesterday morning's session, there was quite a bit of talk about things that resonate with my current job. I look after, you'll see on here that apart from being the Dean of Science, I look after the Western Australian School of Mines. It includes chemical engineering, minerals engineering, mining, energy engineering, and the recurring themes that just shows that chemistry is all pervasive, and if you've got skills in chemistry, you can do anything. The other thing that struck me yesterday was how impressed I was with the quality of the student talks, and I think for those of you who gave your talks yesterday, I sat through the whole session, and I was consistently impressed with the quality of the presentations. I know that a couple of times young people stood up and said, quote, "This is the first time I've ever spoken at an international conference," and I think you all did yourselves proud, so well done. Now, my connection with ITS goes back a few years, and I thought I'd begin with this. Look at that photo there. Now, back in 2012, I went to Surabaya to give an education presentation. Apart from being a chemistry researcher, I've also been involved in chemistry and more generally science undergraduate education innovations, and the last time I was there was 12 years ago. And the photo that began with me, that was a photo that was taken in 2007 when I first became a professor, when I worked at the University of Adelaide, and I thought, oh look, my hair's not grey, whiskers are starting to be grey. 12 years ago, my hair's not grey, and you look at me now and I'm like, I'm ageing. But anyway, what I'm going to do today is talk about some fundamental research. So we heard quite a bit yesterday about the applications of chemistry to various areas, and I'm going to finish up with some ideas and some future directions on where we can take some of the work that we've been doing over a number of years that have been built upon some fundamental work. So I forget the guy's name, but the guy from the mining industry yesterday was talking about the need for fundamental research. He was kind of, singing my song in that sense, because if you do quality fundamental work, unexpected things will come from it, and I hope to be able to show you examples of that throughout the course of this presentation. So I'm not going to read all these words. What I'm really going to do is just tell you a little bit of a story. I've been playing with this idea of using lasers to make metal nanoparticles for, geez, it'd be getting on to 30 years now, but today's just a couple of little case studies on what we're doing. So we won't worry about the motivations other than to say it's fun, okay? I like to have fun. Whoops, geez, that jumped way. Where? Let's go all the... Oh, now I understand. I saw yesterday people have... There's a button underneath. You've got to avoid the button underneath, right? Okay, that's what's... So what I'm going to talk about today is a technique that I refer to as LASIS, laser ablation synthesis in solution. It's to make metal nanoparticles, and the basic idea, go back to the mid-1800s. Michael Faraday in London made the first what we now know as gold nanoparticles. He didn't even call it colloidal gold. If you go back and read his papers from the proceedings of the Royal Society in London, it was called phlogisted gold. What the hell that means. And essentially what Faraday did was he began a process that's been used for almost 200 years now, of taking a metal salt, in the case of gold 3 salts, and reducing the gold 3 down to gold 0. And you make the nanoparticles. And there are various chemicals that are involved in that reduction process. So then if you want the nanoparticles, you've got to separate the nanoparticles from those reduction chemicals, from those byproducts, particularly if you want to use the gold for medical or other type of applications. And the idea of LASIS is, don't worry about the reduction process. Start with a piece of gold. Quite literally, it could be my wedding ring, okay? Quite literally a piece of gold. Put it in the bottom of a cuvette. You'll see a photo in a moment. You can have any liquid you want in here. Today I'm going to talk about water and aqueous solutions. And just focus a high-powered, I use nanosecond lasers. It's been done with femtosecond lasers. A high-powered, typically about 6 or 7 millijoules per pulse at 1064 nanometers. Focus it onto the piece of metal, and it'll make a little plasma, a little discharge. And out of that, 0-valent metal nanoparticles are formed directly in solution. We're going from gold 0 to gold 0. There's no reduction along the way. Well, that was the original idea. You'll see that the chemistry is a hell of a lot more complicated. Technically, these are some of the easiest and simplest experiments I've ever done in my career. No mass spectrometers, no vacuum chambers, no liquid beams, none of that complicated stuff. But the chemistry is some of the most complicated. So, as an example, now I've got to work out which one to, maybe I do press. There we go. I'm going to talk a lot today about UV visible spectroscopy, and I'm going to be focusing on a feature that the nanoparticles have called the surface plasmon resonance. The unique feature of a nanoparticle is they're of sufficient size that the relative proportion of atoms on the surface compared to being in the bulk is very, very high. Normally you've got a larger macro sample and the vast majority of the material is in the bulk phase, a homogeneous environment. Relatively speaking, you've got a large number of atoms on the surface of the nanoparticle. And atoms on a surface, that's a heterogeneous environment. They don't like to be there, they're hanging around. There's a lot of surface electrons. And depending upon the size of the nanoparticle, depending upon the nature of the nanoparticle, depending upon a range of other things, you can excite those excess surface electrons with light. In the case of gold, the reason that gold is kind of gets captured by so much human attention is that the resonant frequency for exciting these excess surface electrons is in the green. So that the nanoparticles absorb green light, and you would all know from your undergraduate days from the complementary colours, if you absorb green light, the solution appears red, has a port wine colour. So let me now jump ahead and talk a little bit about some of the fundamental studies that we've done over a number of years on learning about, it's all well and good to say we're going to focus a high-powered laser onto a piece of gold in solution and make port wine coloured solutions. But what's actually happening? So, here's a picture of quite literally a cuvette, 1 centimetre squared cuvette that you put in a standard UV vis spectrophotometer. Here's a piece of gold that was cut out as 1 centimetre square to fit at the bottom of the cuvette. This is a solution of gold nanoparticles in water where it started off as being colourless, just water, and we focus the laser and the nanoparticles are produced and they absorb green light. So the solution appears this port wine coloured. Everything we see today, this is the surface plasmon resonance, the excitation of these excess electrons on the surface. Everything we see today, I'm going to be talking about shifts in the position of that resonance. I'm going to be talking about whether they're broad or narrow. So all of the spectra have been normalised so that the maximum of the surface plasmon resonance is equal to 1, so that we can look at the shifts. So all of the spectra are normalised, hence normalising in the x-axis. Right, so if starting at the top is just pure water. If I put a piece of gold in the bottom of a cuvette with water and I start irradiating, here we went for up to a couple of hours, bang, 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 you can see that we have a growth in that surface plasmon resonance in the middle there. So what we would see with the naked eye is that the port wine colour is getting deeper and deeper and deeper. The absorbance is going up. The other thing to note, I think I worked out now, right, what this region is in here, this is called the intervalence band, IVB, that tells us that there's more and more and more gold being released into solution. So as we ablate the metal plate, more and more gold is going into solution. But we also see that we have this growth in the surface plasmon resonance here, which is what we're going to focus on. The reason I highlight this here as a sign of there being more and more in solution is later on I'm going to show you some annealing experiments where that doesn't change. Now, if you just make the gold nanoparticles from a piece of gold metal into water, they won't stay around for very, very long, because that extra surface electron activity means that they want to aggregate, they want to bind. And if I go back to the 1850s when Michael Faraday first did his experiments, what he didn't know was part of the reduction process of gold 3 salts going down to gold 0 was he had some encapsulation going on with the chemicals. It was mainly citric acid, it turns out. But with the reduction process going on, the nanoparticles were encapsulated. Think of them as like M&Ms. You know, the nanoparticles, the chocolate core, and the encapsulation is the coloured candy coating around the outside. And that encapsulation stopped or prevented the nanoparticles from aggregating together. And still in museums in London, you have solutions of Faraday's gold nanoparticles that were made in the 1850s. So if you don't put anything in solution, eventually these things will decay away, they'll aggregate, and it takes a few days, but you come back and you find that you've got this port wine coloured precipitate at the bottom of the cuvette and essentially a colourless solution. So we put in some initially negative surfactants, sodium didecyl sulfate, and I started off with 2 concentrations, just 10 to the minus 4 molar, that was enough to stabilise it. And then 10 to the minus 2 molar. And why do I have those 2 concentrations? Because roughly between the 2 is the critical micelle concentration of SDS in water. And I was curious about whether or not, if you remember your undergraduate chemistry, a micelle, all of those surfactant molecules, there's a polar head and a non-polar tail, and those non-polar tails do not want to be in a polar aqueous environment, so they'll aggregate together like tadpoles and create these micelles. And what I was curious about is, will those micelles stabilise and encapsulate the nanoparticle? So in order to test that hypothesis, we went above and below the CMC. Now, I'll cut to the chase and say there is no CMC effect. You'll see that slide later on. We would make these things, we'd use a variety of microscopy techniques. We've used TEM, we used AFM. We can characterise size distributions. And you can see that if you make the metal nanoparticles just in water, there's a peak in the distribution of around about 20 nanometres in size, and it's fairly broad. What we do see is if you're above the CMC, the particles are smaller and narrower in distribution and somewhat in between when there's some surfactant present. And there's a bunch of literature to talk about the details there. I'm just going to give a quick summary today. Now, from those spectra that I showed earlier, where you record a spectrum as a function of time for irradiation, forget about the solid lines in this plot, just look at the data points. What we found, water, pure water, 10 to the minus 4 molar SDS and above the CMC, just the data points. And we can record the absorbance, nothing's normalised yet, the absorbance, the growth in the absorbance as a function of irradiation time, running the laser at 10 hertz for a period of time. Here we've talked about as the number of pulses rather than than time, but it's the same thing. You see a little bit of a curvature down here, and so what these bottom plots are is just a zoom in of the curve and to highlight the curvature. And I've got the error bars in there to show some uncertainty from repeated experiments. And the physical chemist in me says that when I'm looking at this time-dependent data and I see curvature, that's telling me that there is a production channel. We know there's a production channel because the surface plasmon resonance intensity is growing, but there's also a decay channel, and there's a competition between production and decay. So we set about, forget about the curves for the moment, just the data points, we set about trying to understand that. And we came up with this hypothesis that says you start with your gold, my wedding ring, the bottom of the cuvette is bulk gold, and we blast it with the laser, have a little plasma, and essentially we have a model where there are 3 different size regimes of nanoparticles that are blasted out. We can have very large ones that are large enough to support the surface plasmon resonance that we see. There are very small ones. It turns out it's well understood that if the nanoparticle is too small, you can't have a surface plasmon resonance, because it becomes a bit of a philosophical question. When is it just a collection of atoms and when does it become a nanoparticle? Well, one of the ways that you could decide that it's a nanoparticle is whether or not it can support the excess surface electrons with the surface plasmon resonance. So in our model, we hypothesise that these are too small to support the surface plasmon resonance. These are large, they can support it, and there's a medium size in between. And if you have those 3 size regimes all coming from the bulk, you set up this kinetic model that says, in theory, you can transform between any state and any other state. So we've got a rate constant for production of small, a rate constant for the decay of the small. Remember I said the curvature says there's decay somewhere. We don't know where it is yet. Similarly for medium, similarly for large. Transformation between small and medium, transformation between medium and large, and transformation between small and large in principle. Now that's a 12-factor model, and you can fit anything. The more, in kinetics, the more parameters you have, the better the fit is. So the magic is to try to work out the absolute bare minimum number of parameters that you need. And our model, which I'll show you the answer in a moment, is the straight line. So I'm reproducing this curve here, and you can see that our model fits the data beautifully. And what does our model entail to be the absolute bare minimum number? It turns out we need to produce large ones. These are the ones that, don't worry about the numbers, just giving you the idea here. These are the ones that are large enough to support the surface plasmon in supporting size. We need to have the medium ones, okay? But the small ones, this is where we start to think, oh, maybe this micelle idea has some merit, because above the critical micelle concentration, we need to include the channel for the production of the small ones. We don't need it if you're below the micelle concentration. So we thought there was something there. And I talked before about there being a decay channel. Well, it turns out that all of them need this decay channel of the medium ones. So the medium size in this model is, yeah, they're kind of being formed, but they're just kind of big enough to support the surface plasmon resonance, but they vanish again. And with this 3, or in the case of 10 to the minus 2 molar, 4 parameter model, we can fit those data that you saw before. So we believe we have an understanding of how these nanoparticles are being formed from the bulk. And importantly, a lot of them are being formed as large chunks coming out, but there are a lot that are also being formed at a smaller size that may or may not survive, because some of those decay back again, back to the bulk. Notice this channel. They're not transforming from medium to small, they're transforming back to the bulk in this model. Okay, so what I've been talking about is this experiment here. We use 1064 nanometer infrared light from the YAG, and we blast it directly onto the piece of gold, and we get the port wine coloured solution. So let's take the gold out. Let's change the laser from 1064 to 532 nanometers. 532 is near as damn it to, thank you, near as damn it to 520 nanometers. So the green light will be absorbed by this port wine colour, put a little mag stirrer in, and we'll raise the focal point from being down there to being in the middle of solution, and we'll just irradiate. And what do we see when that happens? We do it at pure water, 10 to the minus 4, 10 to the minus 2. The size distributions now are much narrower, very, very small for 10 to the minus 2. So I call this annealing. We can make smaller and more narrow size distributions by the annealing, and we get these beautiful pearl necklace type patterns here in the microscopy. But come back to the intervalence band that I talked about before. I'm not producing any more gold. The total amount of gold in solution is fixed. I'm just changing the sizes from larger to smaller. So you can see that the intervalence band intensity doesn't change, but as we irradiate over 2 hours, the size, and above the CMC, the size of the surface plasmon resonance, the intensity of that absorption decreases significantly. So again, this might suggest that the micelles play a role with the decay. We can create, this is the same transformation model, except we no longer have the bulk there. So instead of having 12 transformation channels, we have 6 transformation channels, and we can look at the change in the absorbance as a function of time, and you can see that we need only 3 of the 6 possible transformations to account for it. And mostly what's happening is in this annealing process, the large nanoparticles are being transformed into medium ones. When there's some surfactant present, medium are being transformed into small. But in the case of the 10 to the minus 4 molar, we need some small ones that are actually growing to medium. So this is where the curvature comes in. I didn't show the time-dependent plots here, but there's curvature again. So this is effectively the decay channel relative to the primary channel there. So again, we can understand the kinetics of what's happening under these circumstances. And this is just the little plot to show that there is actually no critical micelle concentration effect here. What this is various concentrations of SDS, particle size distributions, sort of spread out. They're peaked here at about, 15 nanometers, and the peak is getting smaller and smaller. But you can see there's no, for there to be a critical micelle concentration effect, there's whatever you're measuring, and then there's a sudden change. There is no sudden change. So whatever the surfactants are doing in this case, it's not a CMC driven effect. And we went just above and just below the CMC to be able to test all that. Okay, that's all well and good with SDS as an anionic surfactant. We can change to cationic surfactants. So we used CTAB and CTAC. They're cationic surfactants with halide anions in solution, and we can do the same sort of work with the same model. You can see we went above and below the CMC. Same production model. You can see there's the same sort of decay type ideas here. So this is just a blow up of that little area there, and we can get a range of kinetics. You can see again, we make the large ones directly, we make medium ones, and it's the medium ones that are the decay channel in here, and the surfactants support the production of the smaller size regime. These are the ones that don't support the surface plasmon resonance. That channel is not needed if you don't have any surfactant present. So again, that's just a quick flash to show what's going on. Rushing through this, I want to just, this is a highlight before I get onto copper. We've done a bunch of XPS work, and if you look at the gold in pure water or with the 10 to the minus 2 SDS or with the CTAB, you can see that this is gold 0. These are the 2 peaks, spin orbit coupling for gold 0. But when you have higher concentrations above the CMC of both CTAB and CTAC, we see these extra peaks, and that's gold 3. Now this is really important. This is gold 3 and the surface of the nanoparticles being produced directly during the production process. This is not oxidation of the gold afterwards or anything like that. So if you add, this is the first hint of, if you add some surfactant, you can change the oxidation state of the metal, which is intriguing. I didn't realise the full significance of that until we got onto copper work a little later on. So there's a bunch of work. It's mainly a decade old now. We published all that to say that we understand gold. So I want to quickly go on to case study number 2, which is copper. And the reason I was interested in copper my original hypothesis proves to be incorrect. I was working on the basis that you have these extra surface electrons on the surface of the copper nanoparticle, and if you encapsulated the copper not now with surfactants but with ligands, so we designed some ligands. My hypothesis was you could either have electron donating ligands, and that would add electron density to the surface of the copper nanoparticle, or we could have effectively electron withdrawing ligands that would take electron density away from the surface of the copper nanoparticle. And with this idea of donating or withdrawing electron density, could we shift the position of the surface plasmon resonance, and could we learn about what's going on? That was the hypothesis. Couldn't be any further from the truth. So here's a photo. Here's a little piece of copper gasket. I have mass spectrometers and vacuum chambers in my lab. Turns out the copper gaskets to seal the vacuum chambers are very high purity copper, so it's slightly demunted in shape there because it's cut out from a piece of 6-inch circular gasket. And copper, you can see, has its surface plasmon resonance normalised in the red, so the solution has this pale blue colour to it. Not as strong an absorber as gold, in a different region. Right, so basically I'm going to use neutral type as nitrogen donors that will bind to the copper but not add electron density, and then this extra electron density comes from the negative type. And the hypothesis was, can we look for changes in the surface plasmon resonance feature by using those different ligands, and we can use various microscopy techniques to characterise. So that was the basic idea that we've talked about. And we start with just copper nanoparticles in water, which will traditionally I'll show in grey, and you've got a surface plasmon normalised maximum at about 660 nanometres, which is red, so you get that bluey, pale blue appearance. So I put in some neutral type ligands, phenanthroline, bipi, pyridine, phenylpyridine, and what we see, in fact, even though I've coloured them red, there's a very slight blue shift relative to the grey, but they're similar in width, maybe slightly yellow, nothing particularly remarkable. What I thought was interesting, we have this really cool little instrument in chemistry at Curtin where you can do atomic force microscopy measurements to sit your probe right over the top of a nanoparticle, and then you can shine a laser on it and get a Raman spectrum of that nanoparticle. And what we have here is a Raman spectrum of copper nanoparticles, nothing. This is with phenanthroline. Here's a Raman spectrum of phenanthroline, standard Phen Raman spectrum. And here is a Raman spectrum of phenanthroline encapsulated copper nanoparticles. And there are several peaks, I've highlighted them with an asterisk, that do not appear in the Phen. So that would suggest that there's electronic interaction between the copper and the ligand, which was exciting. So now we go to the electron-rich ones, and what we've effectively got here, these are all tetrazoles. We've got these hydrogen atoms on here, and what happens is when you put them in aqueous solution, that deprotonates, and so these become negatively charged, extra electron density. And look, there's a big blue shift, and they're narrowed up. So I thought, ooh, this is working. We're adding electron density and we're shifting the surface plasmon resonance. This is kind of cool. What happens now if I put these tertiary butyl groups on? So instead of having the proton here, I've got these T butyl groups. What have I effectively done? I've shut down the ability of the ligand to deprotonate in aqueous solution, so they should be behaving like the neutral ones, and lo and behold, they behave like the neutral ones. So I thought, oh, we've got an understanding developing here of what's going on. The shifts in the surface plasmon resonance needed to confirm are not a result of changes in the particle size. Does one ligand type give a broader distribution or a larger size, and a different ligand type gives a narrower size? If there were changes in the size distributions, that could be a contributing factor. And without going into a lot of detail, there are no changes of any significance in the maxima of the size distributions. Yeah, sure, you can get some extra width here, but the peaks are all pretty much the same. You cannot account for the spectral changes by size changes. So the question is, can what we're observing here be attributed to changes in the electron density in the copper nanoparticle? But there was a paper published in 2012 in ChemCom that said that you make copper nanoparticles. These were not made by a laser technique. These were made by a chemical reduction technique. But if you had oxidized copper on the surface of the nanoparticle, you had a SPR resonance close to 660. And if you had oxide-free copper nanoparticles, it shifts to 580. So it could very well be that those two red and blue shifts that I saw have nothing to do with electron density going into or coming out of the copper nanoparticle surface, but it could be the result of whether or not we have oxidized copper or oxide-free copper. As an aside, I was never able to reproduce those experiments, but I'm not a synthetic chemist, so that wouldn't be a big deal. So, what's going on? Well, I put in some oxygen donor ligands. Okay, let's deliberately try and oxidize things. And sure enough, you can see that there's in fact a very slight blue shift this time. Previously, the red used to be grey, now it's red. I'm sorry about that, different slide. Instead of being a very slight blue shift, there's actually a red shift. So nothing radical going on there. Let's put in hydrazine as the ligand. Okay, hydrazine is known to be a strong reducing agent. So hydrazine should, if it's a reducing agent, get rid of the oxidation at the surface, and look at that, it's a big blue shift. So maybe there is something to this oxidation type idea. So, could it be that the ligands themselves are changing, are oxidizing or changing the oxidation conditions of the nanoparticle over time? So here's two plots. The grey one is copper nanoparticles in pure water, and the blue one is copper nanoparticles made in the presence of this 3-pyridine tetrazole, one of the blue ligands. Okay? So now what happens if we take this solution, make it with the laser, and then add the ligand afterwards? Is the ligand itself going to bring about the change in the oxidation state and bring a shift to the blue? If that's the case, then the laser is doing nothing more than just making the nanoparticles, and all the surface chemistry is occurring afterwards. Well, the answer is nah. You add the 3-pyridine tetrazole, and there's no change to the oxidation chemistry as indicated by the UV vis. Leave it in for another 5 minutes. Oops, wrong button. Another 5 minutes, no change. So the important message out of this is whatever is happening to the surface chemistry of the copper nanoparticles in the presence of these ligands, just like in the presence of the surfactants with gold, it's happening during the production of the nanoparticles. It's not a post-production chemical transformation. The other thing that's really interesting is here we have the butylated 3-pyridine. There's the standard 3-pyridine tetrazole. Remember, this is the one where we've shut down the deprotonation channel. Oxygen's present all the time. Okay? So we're not, whatever that 2012 ChemCom paper through a chemical reduction process is suggesting, these changes in the UV vis surface plasmon resonance are not associated with the presence or absence of oxygen on the surface of the nanoparticles. Okay, there's copper nanoparticles produced in pure water in the presence of pyridine, the butylated one, and the tetrazole. Their oxygen is present all the time. So it's not oxide formation. If it's not electron donating and electron withdrawing, and it's not oxide presence or oxide free on the surface, what's going on? Well, let's use XPS and look at the copper. And it turns out this is from a detailed high-resolution paper in 2010, just to justify the modelling we have here. These two peaks here are effectively copper 0 and copper 1, and we can't resolve them. And these two peaks, different spin orbit states, are copper 2. So the important message here is this is copper 0, copper 1. Copper 0 is the main peak, copper 1 is the shoulder, and these peaks over here are copper 2 on the surface of the nanoparticle. So, done a bunch of work, but here we have copper nanoparticles in pure water, and you can see the copper 0, copper 1. Here's the copper 0, copper 1, two spin orbit states, And there's a smidge of copper 2. Okay? All justified there. Let's make them in the presence of the butylated pyridine, and again you can see copper 0, copper 1, copper 0, copper 1, and the copper 2 is more pronounced on this occasion. Now let's put in one of the blue ligands. Look, there's no copper 2. So these ligands appear to be suppressing the production of copper 2 on the surface of the nanoparticle while they're being formed. Now I can go through, there's tons of examples. Here are the two, the butylated and the non-butylated. This can deprotonate, no copper 2, copper 2. And to take all of that data, you can see that there's pure water right there, but for all of the quote-unquote red ligands, there's different percentages of copper based upon the XPS between 25 and 60%, but all of the blue ligands, there's 0 copper 2 present. So it's a consistent result. So we went into high-resolution TEM to see what's going on. I love this high-resolution TEM stuff, because when you can actually... It's one thing to be an undergraduate and learn about crystal lattices and look at diffraction patterns and all that sort of stuff, but to actually see it, I find this really kind of cool. So we did some detailed analysis, and the bottom line, because I know time is short, we also did some selected area diffraction patterns on these nanoparticles. And the important point that comes through repeatedly is that in the red ligand cases we have copper 2. Here you can see the copper 2. And in the case of the blue ligand, there's no copper 2 present. And we can go through this in great detail. These are other high-resolution TEM with the selected area spots. And it's chopped off down here, but whenever there's a blue ligand, there's no copper 2. Whenever there's a red ligand, there's copper 2. There's copper 2 up there, okay? So copper 2 is consistently being suppressed. Here's a regular TEM, and the dashed number 1 is the high-resolution inset there, number 2 is the high-resolution inset there, and again you can see these beautiful lattice fringing patterns, all this detailed work from lots and lots of images, more of it there, comes up with, here's the key conclusion. When you've got a blue ligand, there's no copper 2. Here's bare copper nanoparticles, copper 2. The 4,4-bipi is a neutral ligand, copper 2. The butylated version of the tetrazole, copper 2. But when it's the electron-rich deprotonated, no copper 2 is formed in solution. So the take-home message we've learnt here goes all the way back to when I had higher concentrations of CTAB and CTAC in gold, where gold 3 was being seen for the first time. What we're seeing here is by having different ligands in solution, we can suppress the production of certain oxidation states, and this has significance for some catalysis. So I've talked about all that. The important point is this next one. Okay, those tetrazoles do not act in this reducing, suppressing copper 2 context in traditional coordination chemistry. There are plenty of examples of these tetrazole electron-rich ligands interacting with copper 2. So this is a really interesting example of how the chemistry for nanoparticles, the chemistry in the nano regime, is fundamentally different to the chemistry that's occurring traditionally at the molecular level in a beaker or in solution. And that raises all sorts of interesting questions about how you might be able to use these things. Okay, so I call it the suppression of the copper 2 on the surface, but it's not reduction in the sense of suppressing oxides. It's reduction in the suppressing reduction in terms of the copper 2. So, and it also, this is the other really important point, these ligands need to be in solution at the time of production of the particles. It's not something you can do post nanoparticle production. So where are we going with this? Because I know my time's up. I have a PhD student at the moment, I haven't talked about it today. He's interested in using gold nanoparticles. Gold, in the way that copper has an affinity for nitrogen ligands, gold has an affinity for sulfur-containing ligands, and he's doing this wonderful work. He's got encapsulated the gold with sulfur and attached peptide sequences, short peptide sequences, and those peptide sequences have been chosen because they are effectively food for cells. So cells think, they don't see the cold, they see the peptides, they go, oh, there's food, I'll grab that, thank you very much. And the hypothesis is for cancer treatment. Cancer is uncontrolled cell replication, so on the kinetics idea, preferentially cancer-containing cells will suck up this gold nanoparticle encapsulated M&M type thing. They think, ooh, this is good food, I'll have a few Smarties. When you irradiate a gold nanoparticle at 13.6 megahertz in the radio frequency, they vibrate, you heat them up, kill the cell. So collaborating with some colleagues in our health science faculty on seeing whether we can actually use these for, wrong slide, one thing again, we can do that, and Ziad's doing some great work. For the copper nanoparticles, I'm really interested in being able to control the oxidation state of the nanoparticles on the surface. Opens up a whole range of potential catalysis. Copper's an important, we heard yesterday in a talk, your talk with the copper on the surfaces, okay? There's a whole bunch of potential chemistry that can be happening with the copper. And then what really excites me is, okay, now I'm in a school now with a metallurgy section. We can make all sorts of mixed alloys. My interest in this work started 30 years ago with Tomatsu Kondo at the University of Tokyo when I was a PhD student, more than 30 years ago, was doing some of this work. Mifune, one of Tomatsu's students, kept doing it, a friend and a colleague of mine. They did some really interesting work where they had a gold and silver alloy and they could make mixed alloy nanoparticles. So I know we can make this, but if we can now make catalytic relevant, catalysis relevant mixed metal alloys, that's where we want to go next. And can we control the oxidation state of the different metals on the surface of the nanoparticle? Remember, the nanoparticle has a large surface area, so there's all sorts of potential catalysis. It's fundamental work. We're not going to be producing bucket loads of this stuff for production work yet, but that's where we want to go. So a whole bunch of people have been involved in this work, had PhD students that did the LASIS. I'm not a synthetic chemist, so Max Massey down here, colleague of mine, a couple of his students made the tetrazoles. I had a really talented student, master's student from Southampton, who did the high resolution TEM work, various colleagues. Gohar Jia, who I collaborate with now at Curtin, did further analysis of the high resolution TEM data, and funding to do this work was funded by the Australian Research Council, who gave me the money for the lasers, and Curtin University that gave me the money for the PhD students. And that's it. Thank you. I'm out of time.
Okay. Thank you, Mark, for the really great presentation. And let's go start with the Q&A session. How many times do we have? 10 minutes. Okay. So, yeah, I think you're taking a bit...
The time-out thing you're giving me is time to shut me up, so there's time for questions. I like it.
Yeah. So 10 minutes. Let's open the Q&A session, please. Anyone? Okay. Yeah, Mr. Gracianto.
Okay, thank you very much. Thank you for your next talk. So I would like ask two questions actually. So the first question is about the stability of gold nanoparticle that you prepare. So how about the stability of nanoparticle? Because basically I'm from the analytical chemistry, so for the consideration for the analytical purpose, maybe we need the stable nanoparticle. And then also you mentioned about the application of gold nanoparticle for cancer treatment. So I think like if we use gold nanoparticle for the cancer treatment, the challenge in the, maybe you also know about it, when come to biological environment, for example, nanoparticle is easily aggregate. So like I'm asking you about how the stability of your gold nanoparticle. Thank you.
Okay, so as I mentioned during my talk, if we just make the nanoparticles in water, and it doesn't have to be water. I've done this in ethanol, methanol, THF. You pick a solvent. You can make them in anything. But this talk today is about aqueous solution. If you make them in aqueous solution, gold or copper, they won't last very long at all because there's no encapsulation. Okay? And if there's no encapsulation, then they're just going to aggregate because, in fact, that high... think of the nanoparticle with the relatively high number or proportion of atoms on the surface. They're chemically they've got a high chemical potential. They want to do something with it. So if they aggregate, then you're going to have increasingly, relatively speaking, fewer atoms on the surface, so you're lowering the chemical potential by them aggregating. The encapsulation process shuts that down. That's why I use the analogy of an M&M or a Smartie, where the nanoparticle is the chocolate core and you've got that candy coating around the outside. When you encapsulate, the concentration of the species, if it's in the case of surfactants, if you're above the CMC, I made them 10 years ago and they're still in solution, okay? So not quite the same time scale as Michael Faraday, but you know, they might still be in solution in 200 years' time. Below the CMC, the time with which they're stable depends upon the concentration, and I can only answer that vaguely because it's never been a focus of us wanting to sort it all out, because there's so many other variables at play in there in terms of temperature and irradiation conditions and so on and so forth. In the case of the ligands, everything we did was at 10, everything is at 10 to the minus 4 molar because it's a convenient concentration to work with, and those ligands in solution, they're stable for, again, stable for years in solution. We throw them out rather than hang around with large quantities of them. So the stability is high. In the case of your question about the biological activity, they remain encapsulated. This has been well studied by others. All we're doing here is using the laser-based production approach. So the people that use the traditional chemical reduction approaches, the synthetic ways of making the meta-nanoparticles, once they've made the nanoparticles, they have to go through extensive separation and purification processes to get rid of all of the reductants and stuff like that. We have in solution what we choose to have in solution, and that's it. And they're stable. As long as they're encapsulated, they're stable. So does that answer your question?
Yeah, thank you very much.
Okay, thank you, Mark, and thank you, Mr. Gracianto. Okay, so probably just one more last questions. Yeah, I think we have...
Oh, the microphone's coming, mate.
Thank you, Mark. My question is on the gold. When you have a high concentration of cationic surfactant, CTAC, you have gold 3+. What if you use, like, say, SDS and other anionic surfactant? Do you see the same?
No, I had that in the slide. You don't see the gold 3 with the SDS. And I in the slide, I won't go back now, but I had 10 to the minus 2 molar, the highest concentration of SDS, gold 0 and nothing else.
Do you know what caused that to the gold to oxidize?
No idea, because I didn't really appreciate it until I did the copper work.
Yes.
So that's one of those things where you learn, you want to go back and look at it.
Yes.
So.
Yes. One follow-up, very short one.
Yeah.
On the copper oxide, when you did the XPS, but copper in such small sizes are highly not stable. When you did XPS, how sure are you that it is not because of the sample preparation during the XPS, when they are exposed to the air, the copper can be oxidized right away?
That is, you're absolutely right. That is a risk in what we're doing. What I didn't talk about today, we have another paper in there. I did a bunch of XPS work at the Australian synchrotron with gold rather than copper, and we would record XPS cycling time and time again, and we found we're actually photo-reducing the gold 3 to gold 0. Everything was shifting in time. So it's not just the sample preparation, it's the irradiation process itself that can also change that. So we mapped out all the kinetics for it for gold, but not for copper. I actually asked for more beam time at the synchrotron for copper, and they turned me down. So, yeah, bastards.
Okay. Do we still have time? I think maybe for the other questions.
There's a question up the front here. Oh.
Okay. Just one really short, Professor Akhlus. It's really short.
Oh, he's being a good moderator, isn't he? He's telling you to be short. He's keeping you on a tight leash.
Yeah.
Yes, thank you very much.
He's my senior, actually.
This is a little bit question about theoretical. Let's say theoretical. What is exactly the interaction between atoms?
What is the interaction between the atoms?
Yeah, between, let's say, two atoms in the nanoparticles, okay? And can we separate independently two atoms, according to your experience?
I don't know how to answer that question in the sense that everything that I've been talking about today, we're interrogating the surface of the nanoparticle. We're not interrogating the bulk of the nanoparticle. I interpret your question as the interaction between two atoms in the bulk. But to the best of my understanding, they would be standard metal atom-atom interactions. It's just it's not the bulk. It's a very small size. It's a really interesting. The nanoparticles are an interesting size regime because they're bigger than the molecular scale, but they're smaller than the bulk. But what does that really mean? It's not that the chemistries, the interatomic interactions are different in the nanoparticle. It's the relatively large surface area compared to the bulk in a nanoparticle that invokes all this interesting chemistry, rather than the interatomic interactions themselves. Did I definitely not answer your question?
Not yet, but I try to develop again the approachment of the what is the really interaction between two atoms in the let's say the not nanoparticle but one particles of atoms. Yeah. If let's say we have two atoms, okay? Because you know that the development of the nanoparticles experiments, you can go let's say your copper, you can go to the 150 picometers, yeah. The last and see you 0011 of your yeah. You can go to 0.15, something like that, nanometer. It means that 158 nanometer, your copper atoms, okay? And we know that the diameter of copper is around 120, or yeah, it's smaller than you found in your nanoparticle. It means that maybe when we talk about the atoms itself, we can develop again the.
When I get beginning students to work with me on this project, one of the first activities I get them to do is based upon everything you just talked about: the size of an atom, the size of the nanoparticle. Assume they're spherical. How many atoms are in a nanoparticle? And of course, I want them to come back and tell me there's anywhere between hundreds and thousands of atoms in there. So it's not 1, 2, or 3. It's many, many, many atoms. It's in order to convey the idea that this is not. It's not a molecular-based chemistry process. It is.
Because I talked about the dose. Dose, for example, when you use the gold nanoparticles to kill the cancer or something. Yep. Maybe when we talk about the dose of the let's say the nanoparticle of gold.
But that's another feature of the nanoparticles. If you take bulk gold and irradiate it in the radio frequency, 13.6 megahertz, nothing happens. You take molecular gold complexes, nothing happens. But in that particular size regime, 13.6 megahertz, and they wiggle and jiggle. So it's an ensemble effect rather than a molecular effect.
Okay, Professor Akhlus, I think we have enough more than the time that we need. So if you like to discuss any further, then we can go outside this session perhaps. But thank you so much, Professor Akhlus, Professor Eng, and Dr. Gracianto. And thank you so much for your great presentation, Professor Mark Bontain. And we're going to the next presenter from ITS, Professor Fahima Marta. I mean, we were talking about the gold nanoparticle, and then about the copper nanoparticle, and we're talking about ligand and everything. And Professor Fahima Marta will tell us about, can you show her presentation, please? It's about copper hydrazone complex. So today we're talking about complexes, right? So, and thank you, Professor Fahima Marta, and we're going to hear about your presentation for about roughly same 40 minutes, and we're going to have Q&A session after that. The stage is all yours.
Okay, thank you very much. Assalamualaikum. Good morning, ladies and gentlemen. Thank you very much for hearing me here. My name is Faima Marta. I am from Institute Technology 10 November. Here I would like to discuss about my project synthesis copper 2 hydrazone complex based on benzohydrazide and benzaldehydes as chemotherapy agent. We reset the same Prof. Mark, yeah. We use copper. Okay. Cancer is health issue and cause reduced life. In many countries. Cancer, one of leading causes of death after carcinoma disease. One example of type cancer is cervical cancer. According to WHO data, in Indonesia has highest number of cervical cancer cases in Asia, with a standard 23.3. Sebelum ini, Kak. Oh ya, ya. Okay, thank you. 50% patient with cervical cancer was die. This disease, the second largest contributor after Myanmar. Cervical cancer is tumor caused by infection with human papilloma virus. Hive virus is associated with inactive infection carcinoma of genital. Next. Treatment for carcinoma cancer is carried out through vaccination method. However, this vaccination have serious side effects, increased heart rate. Some other treatment have been carried out: surgery, chemotherapy, and radiotherapy. Among these three methods, chemotherapy is the most feasible for cancer treatment. Again, chemotherapy based complex cisplatin, but platinum can cause body damage such as kidney. Moreover, these drugs are resistant to cancer cells. Therefore, methods such as copper can be used as alternative chemotherapy again. This is a reaction complex copper 2 with ligand hydrazone. Next. Yeah. We use ligand hydrazone, reactivity, selectivity, and toxicity. I synthesis hydrazone from benzaldehyde and benzohydrazide. Next. On the other hand, effectiveness of drug action depend on choice the ligand. Characteristic ligand play important role in the drug activity. Ligand can be used is hydrazone. When carbonyl added to hydrazone, next, to form acyl hydrazone. This is ability protein binding, stability, and inhibitor in cancer cell. Next. When hydrazone is bound to metal, the therapeutic activity, the material increase. This is C, increase IC50. Next. Benzaldehyde, next. Benzaldehyde and benzohydrazide was reflux under 2 hours during the was meter monitoring with TLC. Synthesis of the complex, the mix ligand hydrazone with copper 2 chloride by reflux 2 hours. After that, sodium acetate was added until pH 7 and 9. Okay, next. The result, characterization, FTIR, so bond in wave number 3200 indicate amina primer of benzaldehyde bonded from imine CN. Characteristic peak hydrazone and nitrogen and hydrogen aromatic, carbonyl and azomethyl. Next. Both compounds have carbonyl peak, tend to be in the ketoenol. Next. Spectra UVV show 302 and 330 indicate transition and 2p star. Next. Addition hydroxyl cause bathochromic effect hydrogen bond. Next. Okay, next. This is a characteristic NMR hydrogen. Proton of the amida 11.32, proton azometine 8.43, and hydrogen benzene 6.19. Okay, next. Amida bond, CN and benzaldehyde make it isomer A and again. Next. Yes, this is isomer A and isomer Z, but no isomer Z. This is isomer A from characteristic NMR. Okay, next. From NMR ligand carbon 163 cause indicate carbonyl, 143 indicate carbon from amine, 117 indicate carbon of aromatic. From characterization as SCMS, characterization was performed M says Z 300 jersey indicate complex combine potassium and hydrogen. Next. This is from characterization FTIR, NMR proton and NMR carbon. This is ligand. This is hydrazone. This is added glucose hydroxyl to ligand hydrazone. Next, FTIR untuk kompleks copper hydrazone. The same is ligand, but in fingerprint indicate copper in coordination with ligand and copper coordination with atom oxygen. Next. This is from characterization SCMS. This is from complex CU hydrazone. This is complex CU hydrazone substitution hydroxide. Yeah. The mass spec 364 indicate complex combination potassium and hydrogen. In the right, lithium. From TGA complex hydrazone indicate ligand hydrolysis. (119 to 300) release 1 molecule hydrazone. Next. Okay, next. This is 1 molecule hydrazone. Okay. From SRD indicate a structure of the complex triclinic. As next. This is I refinement untuk obtain a structure of the crystal with retica program. Next. Okay. UV-vis complex copper 2 hydrazone and 2p star in 270 and transition P to P star, so 319. Okay, next. This is P to P star, indicate aromatic benzene. This is a complex my synthesis. This is copper L ligand nitrohydrazone, geometri tetrahedral untuk 6 hydrazone 3,5 dichloro tetrahedral in the research before, yeah. Next. In my research, structure 3 clinic. This is square planar untuk for copper 2 in hydrazone, for copper 2 hydrazone with substituent hydroxida, square planar is the same as the structure. Yeah, this is indicate tetrahedral. Yeah. Next. Yes. Okay. Agak susah ya. Ya ini sudah tadi. Next. This is uji test activity for the cell HeLa indicate IC50 200 indicate complex enough reactive. Yeah. Okay. Next. This is a substituent function group hydroxyl, the same, yeah. IC50 more 200 microgram per milliliter. Next. This is the complex increase 7.56 microgram. Indicate the complex more reactive than ligand. Okay, next. Okay. Okay, thank you very much.
Right, okay, thank you, Prof. Fahimah Marta, and we're going to open question and answer session. Is it okay? Okay, so we're going to open the Q&A session, and I will help Prof. Fahimah if you need some help, perhaps, then we can discuss. Okay, is there any questions from the audience?
Yeah, I synthesis to ligand hydrazone and ligand with substituent hydroxyl ligand. This is I complex. I synthesis the complex. So the complex loss inhibitor power cell HeLa more reactive than ligand.
Okay, so is this the end? Oh, okay. So yeah, I'm sorry that. Sure. Do you have any question? Right.
How do you compare the solubility of these ligands with cisplatin? Maybe the aqueous solubility between your ligands and cisplatin.
More reactive cisplatin than my ligand, but in cisplatin side effect. Yeah, this is side effect because more reactive. So damage body system. As example kidney. Ya, itu.
So the cisplatin have more side effect to the body.
Yeah.
Okay.
And
But
resistant.
it's stronger than your ligand.
Yes, yes.
Okay.
I change platina with the copper too as alternative.
Okay. Is there any more questions from the audience? Oh, okay. It's not yet. We still have a few times, a few more times. Yeah. I'm just because this is not really my my expertise, but I'm just wondering. When you're showing your NMR data, have you ever tried to check it with the 2D NMR analysis, something like that? You're using maybe COSI or SSQC or SMBC. Have you ever tried that or not?
No, I use NMR proton and NMR carbon.
Oh,
No,
yeah, but haven't used the
never use
2D NMR.
NMR too.
Yeah, two-dimensionals.
Yeah, 2 dimensional.
Not on. Okay, not yet. Okay. Right. Okay. Since we don't have any more questions from the audience, we're going to close this keynote presenters. Let's have applause to Professor Faima Marta.
Thank you very much.
Thank you so much. And I will return this session to our Master of Ceremony, Mr. Haikal. Thank you so much.
Okay, thank you so much, Mr. Henrietta Solistio Putro, as being a moderator for today. And can I get once again an applause for our keynote speaker? It's an amazing opportunity to listen to them and about their research and seeing how passionate they are in researching and doing what they love. So next up, before we go into the parallel sessions, we're gonna have another photo sessions. And we're gonna have some giving of the token of appreciations to our keynote speaker. In this case, we're gonna invite Mr. Samshir Ahlus to the front to give the token of appreciation to the speaker, to the keynote session. And we invite Professor Mark Bunton and Professor Mark Bunton first to the front to receive the session to receive the token itself. Okay, thank you so much, Mr. Professor Mark Valentine. Next up, we invite Professor Fahimah Martak to receive the token of appreciation as well. Okay, thank you so much, Professor Ahlus, as the one who gave the token of appreciations. Next up, we're gonna have, this is the end of today's keynote sessions. And after this, we're gonna have a coffee break and also and poster sessions outside. So you can see some research that has been made into a poster. And you can see them, present them as well. So at 11:30 p.m., please go back into the room, into the parallel room, each parallel room, and then we're gonna start the parallel sessions at 11:30. So for right now, all of the people here can enjoy the coffee break that we already have done outside of this room. And the last one, probably, just for a reminder, after the session itself, after parallel session, please do come back to this room because we do have a closing ceremony and closing sessions of the ISOC 2024. But I think that's all that we can say for now. And please enjoy the coffee break and you can go to the parallel sessions. Thank you so much.
So the ligands or the surfactants encapsulate it so that they can't bind. They can't get close.
For example, what happened to this is a gold particle. Okay, this is a silver particle.
I see where you're coming from.
Yeah.
So yes. I've not done that experiment. No, so what you're suggesting is if we made bare gold nanoparticles in one experiment, bare silver nanoparticles in another experiment, and poured them together, what would happen? That's a really good question. I don't know.
Why do not just make
because then the question becomes, will the gold particles prefer and the silver particles prefer, or will they make an I've never done the experiment. I don't. That's a good question. That's a good question.
1973, with General Importer as core of its business, PT Fajar Mas Murni has marked the beginning of its glorious journey. In its first office in Menara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to 4 business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Mas Murni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Mas Murni is providing the first-rate after-sales service in its field of business. All aligned with PT Fajar Mas Murni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
Okay. Good afternoon, everyone. Good afternoon, ladies and gentlemen. Welcome to the second day of parallel session in ISOC 2024. And I am Kartika Noraga Madurani from Chemistry Department and will become your moderator for today. So for the first, we have one invited speaker and also two speakers for the first session, and after lunch we have around 9 speakers. So first, let me introduce our invited speaker. He is Professor Adi Setio Purnomo from Chemistry Department, ITS, and he is a professor of biochemistry. Professor Adi, are you ready? Okay, you have 25 minutes for present your work and then 5 minutes for Q&A. Please welcome for Professor Adi.
Okay. Okay, thank you very much, moderator. Okay, good morning. I think still morning. Okay, my name is Adi Setio Purnomo. I'm from Department of Chemistry, Institute Teknologi 10 November. And today I would like to give you a presentation about biodecolorization and biotransformation of the methylene blue by mixed culture of Dihydroxyl dickinsi and Trichoderma viridi. Okay, we know that the textile industry is increasing in Indonesia and it's contribute around 20% in this first semester in 2024. However, this textile industry is also have impact in enhance the waterways which directly throw up in the water bodies. And one of the dyes that often used in the textile industry is the methylene blue. And this is the structure of the methylene blue, and this dye have negative property like carcinogenic, mutagenic, and very stable to degrade. And also they have also negative impact on the human health, and also can kill the aquatic biota. So that's why we need to make a proper handling of the waterways. And we know that there is 3 methods that usually used for dye treatment: physical, chemical, and also biology treatment. So in the physical treatment is usually very fast, but they have negative impact that produce secondary pollutant like sludge. And also chemical also very fast, but little bit expensive. And biological is cheap, but also eco-friendly, but most of them is very long time. So today I would like to give the biological treatment for methylene blue. And biological treatment by using fungi is already used by some researcher, and one of them used the brown fungi. These fungus can degrade cellulose and hemicellulose, but cannot degrade lignin, just modify the lignin. And also the brown fungi can degrade the phantom reaction between Fe2 plus and also hydrogen peroxide that produce radical hydroxyl. And one of the brown fungi is the Dihydroxyl dickinsi. This is the fungus. And then some paper already reported that this fungus can degrade DDT in the contaminated soil, also can remove the methylene blue in the very high concentration, 100 ppm, only for 14 days. And also this fungus also mixed with the bacteria and can degrade MB around 89%, only for 7 days. And so to improve the ability of the fungus, we try to make another treatment by mixed with another fungus. So this is the mix with bacteria. Now we try to mix with the fungi, the fungi and fungi. And one of the fungus that we try to mix, we use the filamentous fungus. This is usually used for soil treatment and very easy to grow. It's named at Trichoderma viride. And some paper reported that this fungus can absorb methylene blue and also can absorb also the batic waterways. And we try also immobilize these fungus to the matrix and can decolorize MB around 98%. It's very potential fungus. And we try to treat the MB by using mixed culture of the brown and the filamentous fungus, and then we try to evaluate this ability. So our purpose is to colorize MB and then transform MB to the symbol. We try to characterize the metabolites so we can save the waste in environment. And this is the method. So this is our method. We do the culture preparation and then liquid culture and then MB removal by single culture, and then we compare with the mixed culture and analysis the decolorization rate and also metabolite product. And this is for preparation. We cultivate the fungus, the Deltadicensis or Trichoderma viride in the media agar, and we got the culture. And then we transform from the solid culture to the liquid culture. We incubate for 7 days. So this is the culture, single culture of Dahlia dickensi and also Trichoderma viride. And this is for decolorization by single culture. So for each fungus, we treat with the MB, and then we incubate for 7 days at 30 degree statically, and then after decanted, we analysis by using UVVs. And in the case of the mixed culture, we mix both of them and then treat also with the MB and the same method. And after we got the rate of the decolorization, we also analysis the metabolite by using LCMS. So this is the result. So this is the comparison of the MB decolorization. This is the control without any treatment, and this is the decolorization by dickensi by brown fungi, and this is by Trichoderma viride, and this is the treatment by mixed culture of them. And after we centrifuge, we got the supernatan. This is the control. This is by Dahlia dickensi, this is by Trichoderma, and this is mixed culture. So we can see the difference of the supernatan after treated with the culture. And this is absorbance data. So the blue one is the control, and then this is by dickensi, and the green one by Trichoderma, and the last is by mixed culture. So the peaks still contain the wavelength of the methylene blue. So some of them still contain of the chromophore here, not changed. So based on the absorbance, we calculate the decolorization percentage, and this is the result. They can see only around 6%, and the viride around 64%. So after we mix together, we got the 55% by mixed culture. So we can see that mixed culture give the more effective by compared with the single culture. And then we try to analyze the metabolite. So if we only treat it by the deficiency, we got the two metabolites from the spectra. This is the control of MB, and after treatment, the peak of the MB is decreased. So this indicated that MB was degraded. And then this is the metabolite peak. We got two peaks here, and this is the metabolite. So the metabolite is the methyl site in this the right sets was transformed to hydrogen. And in the case of another metabolites, we got the change of the sulfur here. We got the oxygen. This is the oxidation. This is reduction, and this is the oxidation. We got two different pathway. And this is the degradation product by trichoderma. We also got the two metabolite. So actually we have some peaks, but we only until now we still only got two. And this is the metabolite. We got this function group addition, and also very long chains of the carbon around here. This is quite a difference. And this is by mixed culture. Also we got the control, and also this is the control of the methylene blue. And we got the metabolite. First metabolite is here. It's quite high peak. So it means that this concentration is very high. We got this metabolite similar with trichoderma, but different functional group. And also another one is this metabolite. We also got the carbon change, long carbon change here. And also we got this function group change with the oxygen here. So based on this metabolite, we try to make like a degradation pathway. See, we combine the single culture and also mixed culture. So by deficiency, the methylene blue transformed to this metabolite, and also compare with this. And then continue here. And then by trichoderma, they get two kind of the pathway. First, they make like this, and then another one chain in this side. And then by mixed culture is we propose that this continue from this part. So maybe after the deficiency convert the methylene blue to this metabolite, and then stability maybe help this metabolite to transform to this metabolite. And also this is also continue to convert to here, because teferidity is very dominant compared with deficiency based on the degradation rate. And teferidity is most of them is at some long chains carbon. So we think that this mechanism is doing by trichoderma. So for conclusion, we got that mixed culture have the best activity compared with another around 55% compared with only single culture by deficiency only 6, and also trichoderma only 64. And we used the quite high concentration of the methylene blue. We had 100 ppm, and based on the LCMS analysis, we identify some metabolites from the deficiency, single culture of the deficiency, and also a single culture of teferidity, and also for mixed culture. So this is my presentation. Thank you very much.
Okay, thank you very much, Prof. Adi, for your nice presentation. So we still have 10 minutes for Q&A. So please, if you have a question, you can raise your hand. Is there any question? Yes.
Professor, thank you very much for the very interesting talk. I want to ask you, what happened to the metabolite products? Now you have identified them. Do they pose higher environmental risk? Meaning, are they more toxic than methylene blue? That's the first question. And the second question, what is going to happen to those products? Do they stay there, or do they serve as substrate for further decomposition by the mixed culture? Thank you.
Okay, thank you very much. That's very good question. So, in some case of in my research, that methylene blue degraded to the more simple metabolites. So it's mean that maybe most of the simple metabolite is less toxic compared with the bromely compound. But in this case of our research, so only maybe if compare methylene blue with this, so the methyl group was removed, changed with H. This is more simple structure, yeah. So maybe I believe that maybe this compound is less toxic compared with this. But in the case of this is not simple but more complex. So yeah, we still we don't know why this fungus make this structure, because maybe they have some purpose to make this change. So this like more hydrophobic, because they have more carbon chains. But I believe that's the most thing that microorganism will do is try to make metabolites less toxic for them. This is most important. So after that, they continue to degrade. But most of first purpose, they try to make like less toxic. So they try to change the toxic group with the more suitable for them. So we still try to make searching why this metabolites formed by this fungus. Okay, thank you.
Is there any question? No? Okay. Prof. Adi, I just wondering a bit, why you only use only one structure or only one compound of the fungus, or you use all of the compound in the fungus to decoloration methylene blue?
Yeah. I only use MB. This is we try to degrade this dye. Yeah? This is MB, and the fungus transform this dye into some metabolites. So they have different pathway. So this is also Dickinson like this, and then Teferidae like this to form this metabolite. And after the mix, we got the new metabolites again. So we propose this metabolite, this pathway, but this pathway is not fixed. It can be changed. So we try to propose this, but we try to make some paper to compare our research. This is true or not the pathway, but this pathway can change after we study more.
Okay, so this is the possibility of the mechanism.
Still this possibility based on our identification of the metabolites.
Okay. Oh yeah. please.
Thank you, Prof. Hadi. I'm just curious in the chemistry way, following the previous question. You mentioned earlier that the fungi tried to eat or consume this methylene blue, so or process this methylene blue so that it will produce a less toxic, less harmful compound to them. Okay. So my question is like, have you ever conduct future research regarding the fungi after they are processing this food, whether they are still alive or whether they are more productive or maybe something like that? Because it's very interesting for the fungi, maybe it will prolong their life or something like that. Thank you.
Thank you very much. Yeah, the fungi still alive, of course. They not dying. But we stop the reaction only for 1 week. So for 1 week we stop and we extract the supernatant and then we analyze this. But if we continue incubated for maybe for 1 month, the fungi still grow. But I think the best way is this is also I have some idea that maybe I can compare these results. So we got this supernatant from treatment by during after 7 days. So maybe the best way to know that okay, this way is produce less toxic. Maybe I will conduct the toxicity test for these results. Maybe by using some plants or something, and from this we can prove that okay, after mixed culture, the toxicity of supernatant is less than other ones, even though the metabolite is still big. So maybe this is also I will try to compare these results to know the toxicity. So if this is the best one, is okay. Okay, thank you.
Okay, very nice question. Is there? Oh, okay, time is up. Okay, thank you so much for Professor Adi. It's very interesting study. We know, yeah.
Yeah, thank you very much.
And then before we go to the next speaker, we have a certificate for invited speaker. Maybe can I ask Mr. Trianda to give for Professor Adi? Okay, now let's move to the speakers before we have lunch. We have 2 speakers. The first is Sylvia Abdi Pratama. Okay, and then Hadiata Karima Milah. Okay, you are ready. Okay, now please welcome for Sylvia Abdi Pratama with the paper methylene blue removal using immobilized Pseudomonas aeruginosa in alganate PVA matrix. You have 15 minutes for presentation and also Q&A. Okay. Okay, are you ready, Sylvia? Yes, please welcome Sylvia.
So, Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Here I'm Sylvia from Chemistry Department of Institute of Technology 10 November, and I'm going to present my research, and it also under Prof. Aditya Purnomo's supervision, with the title Methylene Blue Removal Using Immobilis Pseudomonas aeruginosa in Alginate Polyphenol Alcohol Matrix. So let's start it. As we know, environmental pollution in water bodies caused by synthetic dye effluents is one of the global problems faced by many countries, which is in the dyeing process, 10 until 15% of dyes are discharged into the environment in the form of wastewater. And one of the cationic dye that extensively used in textile industry is methylene blue or MB. But however, the discharge of methylene blue in water bodies can cause several health and environmental risks. Conventional wastewater treatment methods frequently encounter challenges in effectively eliminating MB from effluents, highlighting the necessity for developing innovative and sustainable treatment approach. So, bioremediation as an alternative method has been offered because it's utilizing the metabolites capabilities of microorganisms, efficient, cost-effective, and also eco-friendly. And among all of the microorganisms studied, Pseudomonas aeruginosa has demonstrated notable potential for dye removal due to its ability to produce diverse enzymes involved in the breakdown of aromatic compound. Based on previous study, Pseudomonas aeruginosa has known to have ability in dye removal, including methyl orange, methyl red, and also reactive blue 172. However, the use of direct application of free cells of bacteria in wastewater treatment can be limited by manufacturers such as cellulose, and then the sensitivity of environmental condition and also difficulty of biomass recovery. So therefore, enhanced bioremediation through immobilization method has been offered. And many materials that can be used as the material for matrix immobilization, including alginate and polyphenol alcohol. The alginate component contributes to the matrix biocompatibility, and gel-forming properties will PVA enhance its mechanical strength and stability. And the immobilization matrix can be prepared by many cross-linking agents, and one of that is calcium chloride. So the aim of this research was to evaluate the effectiveness of this immobilization strategy in enhancing MB decolorization efficiency, elucidating the underlying mechanism, and assessing the reusability of the immobilized system. And kinetic and isotherm studies were also carried out to understand the MB removal rate and MB absorption patterns on the immobilization cell. And this is the methodology. The methodology for this research was started by preparing the Pseudomonas aeruginosa through regenerating it in NA media and inoculating it in LB media so we could get the prepared Pseudomonas aeruginosa cells. And the next step was hydrogel preparation in bacterial immobilization that was conducted by alginate 2% and PVL 4% mixed in demineralized water until 100 milliliter and heated to 100 degrees Celsius, and then bits forming by dripping the hydrogel using syringe, coating in calcium chloride solution, and through decantation we could get bits alginate PVA immobilized Pseudomonas aeruginosa. And this is for MB removal assays. We conducted with bits 3 grams of beads and then incubate in 10 milliliter of methylene blue and incubation on 37 degrees Celsius, 140 RPM for 24 hours. And sample after MB removal, we centrifugate it and filtrate was analyzed at wavelength 994 nanometer. And about beads reusability test, we conduct it with sample of MB removal assay cycle 1. And the bit has washed with sterile demineralized water for 3 times, and bits has used in the next cycle of MB removal until 4 cycles. And for this is adsorption kinetics in isotherm studies. For adsorption kinetics, we conduct with the treatment of contact time between 5 until 180 minutes, and the results were analyzed using pseudo first order and pseudo second order kinetic models. And the adsorption isotherm studies was conducted by treatment of MB initial concentration between 25 until 300 ppm, and the Lamouir and Freundlich isotherm models were used to analyze the equilibrium adsorption. And about bits characterization, bits before and after MB removal was characterized using FTIR and XRD, and also the ligninolytic enzyme analysis, including lactase and manganese peroxidase, also conducted in this research. And the next is the result. The removal of MB from aqueous solution in this research was investigated both free in immobilized cells of Pseudomonas aeruginosa, and the results show that the immobilization may enhance the effect of MB removal capacity of the cells. Meanwhile, the role of bacteria is also evident when compared to alginate PVA-PA beads that only achieve a % removal MB of 43.12%. And the observed MB removal in alginate PVA-PA beads can be attributed to the two primary mechanisms, including adsorption and degradation. Firstly, adsorption process has occurred in the beads through electrostatic interaction between cationic dimethylene blue and also the cell wall of the bacteria. In addition, MB degradation occurred through enzymatic process by the bacteria using many enzymes, including lactase and also manganese peroxidase. And this is for beads characterization. This XRD pattern of alginate PVA-PA displayed a mix between alginate and PVA material in the beads, that is, have peak at 2 theta at 12.1 and 19.7. And the next is the FTIR spectrum of alginate PVA-PA beads that exhibit characteristic peak corresponding to the material that include of the beads, that is alginate and PVA. But after MB removal, there is many change in the beads, such as for the carboxylate asymmetric stretching and symmetric stretching have shifted to low wave number, and also there are C and double bond stretching in the beads attribute to the interaction of MB and beads. And this is the absorption kinetic study result. The R square value, which is closer to 1 in the second order model approach, indicated that MB adsorption on the surface of the beads occurred through chemisorption. And also the adsorption isotherm studies showed that alginate PVA-PA beads in this research tend to follow the Lamouir isotherm model with a monolayer MB adsorption pattern. And this is the result of the effect of factor affecting in MB removal. The first is about time incubation. In time incubation, we know that the optimal time of incubation is 48 hours, and in pH case, the optimum pH is 7, around with the pH range in this research is 3 until 11, and also the temperature is 35 degrees Celsius. And this is the result of the reusability of beads. Yes. The reusability of alginate PVA-PA beads was assessed to determine the potential for repeated use in MB removal, and the beads exhibit the promising capacity for reuse, maintaining a high level of MB removal efficiency across 4 consecutive cycles. And this is the ligninolytic enzyme activities, which is PA free cell and PA immobilized in alginate PVA beads in this study, has the activity of lactase and manganese peroxidase that used to degrade methylene blue. And finally, this is the conclusion of this study. Immobilized Pseudomonas aeruginosa in alginate PVA matrix is a promising method for removing MB, and the removal mechanisms involves both adsorption and degradation, and immobilization system exhibit reusability, making it a sustainable and cost-effective approach for wastewater treatment. I think that's all from me. Thank you so much.
Okay, thank you so much. Okay, we have 4 minutes for Q&A. Is there any question? Yes, please.
Okay, thank you for the opportunity. I want to ask you, in your result, why did the Pseudomonas immobilis in the matrix has lower enzyme activity than free cells? Okay, thank you.
Okay. Yes. Yeah. Thank you for the question. So in this research, because we test in the supernatant of MB removal, so we need to extract the enzyme first, and then we test for the ligninolytic enzyme. So for the free cells of Pseudomonas aeruginosa that we use to MB removal, it automatically secrete the enzyme to the solution of MB. Meanwhile, for Pseudomonas aeruginosa immobilis in alginate PVA, most of the enzyme was secreted in the matrix and shielded by the matrix. So when we extract the MB solution, we cannot get more activity of lactase and mangan peroxidase because it's not a total activity of all the enzyme that projects there. I think.
Okay, it's clear. Okay, times. Oh, we still have 2 minutes. Maybe there is a question. Yes, please.
Thank you very much. Your results suggested that there are two possible mechanisms for the removal of methylene blue, right? One is chemisorption, and the other one is degradation. Now, probably the bacteria are the one responsible for degradation, and the non-living organism in your beads are the one responsible for the chemisorption. So my question is, did you try the beads without bacteria, and how does it, perform in removing the methylene blue?
Yeah, thank you so much for the question. So let's back of the slide in the first slide of the research. So yeah, actually in this research I conduct to also alginate in PVA without microorganism immobilis in the beds, and the result is a percentage of the decolorization of or MB removal is lower than with the bacteria. So I think because the bacteria that immobilis in the beds, it also can degrade the MB, while if only beds, it's just absorption process, not with degradation. Yeah. Thank you so much.
Okay, thank you so much. Time is up. Okay. Thank you so much once again for Sylvia Abdi Pratama.
thank you.
Let's give applause. Okay, next speaker from Hadiata Karima Milah with the title Optimization of Methyl Orange Biodecoloration by Pseudomonas aeruginosa immobilized in SA PVA bentonite matrix using response surface methodology. Okay, are you ready?
Yes.
Okay. Okay, for Hadiata, time is yours.
Okay, greetings to all the honorable attendees of International Seminar of Chemistry 2024. I'm Hadiata Karima Mila, and in this occasion I would love to present my current research entitled Optimization of Methyl Orange Biodecolorization by Pseudomonas aeruginosa immobilized in SA, PVA, and bentonite matrix using response surface methodology with the authors including me, Hadiata Karima Mila, Adi Setio Purnomo, and Ichiro Kame. These are the outlines of my presentation today, including introduction, experimental, result, and discussion, and will be closed with conclusion. So we all knew that the contamination of water bodies by organic synthetic dyes has been a worldwide problem due to its toxic nature, and production of organic synthetic dyes reportedly reaches 800,000 tons per year for application in various industrial sectors, and up to 50% of these dyes are lost in water bodies during dyeing process. And metal orange is one of the widely used ISO dyes in various industrial sectors, and it is difficult to degrade naturally due to its stability. And MO wastes are toxic, mutagenic, carcinogenic, and harmful to the aquatic ecosystem. Various conventional methods, both physical and chemical method, has been used to treat MO waste, including coagulation, flocculation, adsorption, and electrolysis. Yet most of these conventional methods require higher cost and leaving toxic sludge. Therefore, we use bioremediation as biological approach to treat MO waste because it is a promising alternative that is environmentally friendly, relatively low cost, and efficient. Pseudomonas aeruginosa, or PA, is a versatile microorganism that have metabolic capability to degrade a wide range of pollutant, and free cells of Pseudomonas aeruginosa, or in a mixed culture, have the ability to degrade methyl orange, as shown in this slide, and it shows that Pseudomonas aeruginosa can produce the enzyme that could degrade methyl orange. But free cells of Pseudomonas aeruginosa have limited application since it is highly sensitive to environmental changes. Therefore, we use immobilization techniques so that the PA will be able to withstand temperature and pH change, as well as the exposure to hazardous substance. And it is also can be reused for multiple decolorization cycles. These are the immobilization metrics that I used in this research. There is sodium alginate because it is biodegradable, non-toxic, and have good diffusion rate, but it has low mechanical strength. Therefore, we add polyphenol alcohol that has excellent mechanical strength, but polyphenol alcohol will limit the mass transfer. Therefore, we add bentonite in the matrix. In this study, we're going to decolorize methyl orange using PA that we immobilize in SA, PVA, bentonite matrix, but we are still uncertain about the optimal condition for this decolorization. Therefore, we optimized these decolorization conditions using RSM, box Benken design, and the aim of this study is to optimize MO decolorization by Pseudomonas aeruginosa bacterium immobilized in SA, PVA, and bentonite matrix. For the culture condition, we inoculated PA stock to nutrient agar and incubated it for 24 hours at 37 degrees Celsius in incubator, and after 24 hours, the PA will grow in solid media and was inoculated to Luria bertani broth and incubated for 24 hours with shaker in 120 RPM, and we obtained PA preculture, and this preculture was transferred to the main culture. And the main culture of PA will taken and centrifuge for 10 minutes at 2000 RPM, and the filtrate was removed so that we obtain PA cells. For immobilization matrix, here we mixed 6% of SA and 4% of PVA with per volume, and they both were diluted in demineralized water and stirred and heated at 105 degrees Celsius until both of them completely dissolve. And we add 1% of bentonite to the mixture and stirred and heated at 105 degrees Celsius. And then this mixture was autoclaved for 15 minutes at 120 degrees Celsius, and we obtained sterile SA PVA bentonite matrix and was added with PA cells. And this mixture was dropped in 4% of calcium chloride solution and was soaked for 24 hours in the same solution, and then it was rinsed with demineralized water to remove excess calcium chloride, and we obtained immobilized PA beads. For MO decolorization, we use RSM using Design Expert, and for the independent variables were pH, temperature, and incubation times with low and high level as shown in this slide. And we obtained 15 experimental run from RSM. And then 10 grams of immobilized PA beads was added with 10 milliliters of methyl orange, 50 ppm at pH of 4, 7, and 10, and was incubated at specific condition according to RSM. Then we measured the absorbance using spectrophotometer UV-Vis at 465 nanometer wavelength, and we determine and optimize the decolorization response using RSM. After we obtain the optimal condition, we verify the result, And we also tested out the reusability test for the bits to see how well a bits will perform on methyl orange decolorization. This is the bits that we fabricated before with composition of SA, PVA, and bentonite of 6%, 4%, and 1% weight per volume that it produced round and dense bits. These are the 15 experimental runs that generated by RSM, and here is the decolorization response we obtained from actual experiment. And the highest decolorization that we obtained is at the 5th run with pH of 7, temperature of 37.5 degrees Celsius, and 6 days of incubation, which we obtained decolorization of 88.25%. And this is the analysis of model that will be used in RSM. This model analysis will explain how much the model will fit the data. And according to RAIM, a model should meet 3 criteria for it to meet a satisfactory, which is the p-value should be less or equals to 0.05, lack of fit value should be more than 0.05, and adjusted R-square should be more than 0.8. And quadratic model is the only model that meets all those 3 criteria, while the cubic model doesn't have lack of fit p-value, so that the quadratic model was chosen in this experiment. These are the ANOVA of quadratic models from this research, and the model is said to be significant because it has less than 0.05 p-value, so that this model is able to explain the data that we obtain from this research. This is also applied for the pH, temperature, and incubation time as the independent variable used in this research. And pH, temperature, and incubation time are significant to the response. And for the lack of fit, this lack of fit measures the inaccuracy at the model at each design point. And this model is have inaccurate lack of fit, so that because the p-value is more than 0.05. This is the linear regression equation we obtained from this model, and this equation will be used to predict the decolorization value. And the decolorization value that is predicted by RSM will be compared with the actual value from experiment, and we obtain the residual value, which is the difference between actual and predicted value. And we also obtain the predicted versus actual value graph. And based on this data, quadratic model is suitable in predicting the decolorization response since the residual value is not really big. And this is the 3D response, and this is the 3D surface from a quadratic model. And as shown in this slide, the center point is in the middle of the surface, indicating that the selected upper and lower limits are appropriate because the optimal value is in the selected range. And after we did numerical optimization, we obtained that the optimal condition for MO decolorization using PA immobilized in SA, PVA, and bentonite matrix was at the pH of 6.64, temperature of 35.083 degrees Celsius, and incubation time of 7.6 days with percent decolorization predicted was 89.117%, and we also verified the result that, and we obtained the decolorization response was 89.101%, and there is 0.116% difference of decolorization response that comes from the error factors that occurs during the experimental process. This is the reusability test from the bits and for 4 cycles, and as shown in this slide, PA that immobilized in SA, PVA, bentonite matrix can decolorize MO more than 70% in each cycle. That indicates that these bits we fabricated has good performance. And for the conclusion, MO decolorization was carried out using immobilized PA in SA, PVA, bentonite matrix, and according to optimization using RSM, Box-Benken design, quadratic is the fittest model of this research with independent value of pH, incubation time, and temperature with decolorization as the response. With optimal condition, we obtain at pH of 6.64, temperature of 35.083 degrees Celsius, and incubation time of 7.6 days. That's all for me. Thank you.
Okay, thank you so much. Okay, we have 4 minutes to Q&A. Yes, please.
Okay, thank you for the opportunities. I'm just wanna know that you said before that the bits was already formed when the SAPVA bentonite matrix was dropped into the calcium chloride solution. But why were the bits soaked for another 1 day before they were washed with demineralized water? Does it has an effect that the condition of the bits itself? Thank you.
Okay.
Yes.
Okay. Thank you for the question. So, calcium chloride in this research act as cross-linking agent, which is when alginate is dropped in calcium chloride solution, the calcium cation will react with the alginate and it form hydrogel bits. And when it first dropped in calcium chloride solution, only the outer part of the bits is reacted with calcium cation. So when it's soaked for another 24 hours, it will help the calcium chloride to penetrate into the inner part of the bits, so that the inner part of the bits will form hydrogel bits as well. So the bits will be more stable. Thank you.
It's okay? Okay. We still have a time? 3 minutes? Okay. Yes, please.
Yes. Thank you. I want to ask you, why do you choose Pseudomonas aeruginosa for this application and not another type of bacteria? Because from the literatures that I know, PA is one of the most pathogenic bacteria in the environment. Yeah, so why you choose the bacteria, and is there any risk of application that can be mitigated by this modification? Thank you.
Okay, thank you for the question. So, Pseudomonas aeruginosa is a bacteria that will easily found in soil or water. And based on the previous research, there is someone that did the research of MO decolorization using various bacterial strains such as Bacillus subtilis and many more other strains. And the result was Pseudomonas aeruginosa perform the highest decolorization of methyl orange. Therefore, in this research, I choose Pseudomonas aeruginosa as biodecolorization agent of methyl orange. And for the Pseudomonas aeruginosa risk, since it is a pathogen bacteria, we haven't do the research about that, so it is still unknown, I guess.
Okay, it's still unknown. Okay, is it clear? Is it clear? Oh, okay. 2 minutes. Oh, 1 minute. 1 minute. Okay, please.
Okay, thank you for the opportunities. First of all, I want to appreciate about your presentation, and I want to ask a question. In the reusability test result, you finished that the decolorization stopped in the 4th cycle, and why you did not continue to the next cycle?
Yes. How about the next cycle?
Okay, thank you for the question. So, when bits is exposed to methyl orange, the cross-link between alginate and calcium cation slowly weakened. So, when I continued for this 5th cycle, the bits was already fragile, and it could probably cells of Pseudomonas aeruginosa is exposed to the surrounding media. Therefore, I stopped the reusability test in 4 cycles.
Okay, it's okay, right? Okay. Okay, time is up. Thank you so much for Hadiata. Yeah. Thank you. Please give applause. And this is the end of the first session in parallel session. We will have a lunch to take a break until 1 o'clock, 1 p.m. So please come back to this room for the next parallel session. We have 9 speakers. Okay, so see you again in the next session.
Okay, is there Daniel Hadiata here? No. And I think, is there anyone who want to change the PowerPoint that they already been submitted before? Nope. Okay. If there's none, please enjoy the lunch downstairs. Thank you.
In year 1973, with General Importer as core of its business, PT Fajar Mas Murni has marked the beginning of its glorious journey. In its first office in Menara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to 4 business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Mas Murni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Mas Murni is providing the first-rate after-sales service in its field of business. All aligned with PT Fajar Mas Murni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
ilmuwan, walaupun ada yang offline, ada yang online, sehingga acara ini hybrid. Tetapi secara garis besar kita dapat mendapat pencerahan, ilmu-ilmu baru.
Audio Jungle.
So I'm from the advanced medical technology research center. I'm at University Technology Malaysia Singapore.
So, like I showed just now, we have the operating temperature of the PMFC up to 120 degrees C. So we try to find out or to determine whether our membrane is capable to withstand with this temperature, right? But in terms of the gas evolved, we never try with this TGA approach in order to determine what type of gas evolved during the operation.
Catalytic conversions. Before we start this process, also prepared previously for the catalyst. In this research, we use 0.08 in molar ratio alkaline catalyst, namely potassium hydroxide.
My name is Heriberto Diaz. I studied in my bachelor and master's of science in Mexico.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih semua. Alhamdulillah acara ISOC saat ini lancar dengan baik dan mudah-mudahan menghasilkan ilmu-ilmu yang bermanfaat dan dapat dipublikasikan jurnal yang lebih baik atau posting yang lebih baik. Mudah-mudahan pada kesempatan yang akan datang dapat diperbaiki untuk memperbaiki mutu dari penampilan dan kualitas dari acara ini. Terima kasih atas bantuan para pimpinan ITS, kemudian Dikti yang memberikan pendanaan juga, kemudian departemen yang memberi fasilitas dan fakultas, dan teman-teman semua. Saya mengaturkan terima kasih yang sebesar-besarnya sampai terselenggaranya ISOC ini berjalan lancar dan tertib. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
Welcome to the Chemistry Department Faculty of Science and Data Analytics, Institut Teknologi 10 November, Surabaya. The Chemistry Department of ITS has plenty building facilities for students to use. For instance, classrooms with capacity of 40 to 50 persons, each with LCD projector, AC, and Wi-Fi. Trial rooms for final project presentation and thesis. And discussion space at the corridor. The chemistry office for administration is placed on the second floor. There is a waiting room, office area, discussion room for lecturer, lecturer rooms, and prayer room. There is also a small library on the fourth floor. Due to the pandemic, during this past year, most learning has been conducted online, generally via Zoom. ITS has Moodle-based learning platform called My ITS Classroom. In My ITS Classroom, students and lecturers can find out which courses could be taken in a particular semester. There are also several activities that can be carried out. For instance, uploading files, both lecture files and videos, managing face-to-face meetings, doing assignments, arranging exams. There are 6 laboratories consisting of 1 educational laboratory at the Fundamental Chemistry Laboratory and 5 research laboratories that can support the students' research and learning activities. The other 5 laboratories, the research laboratories, consisting of the Instrumental and Chemical Analysis Method Laboratory, the Microbiochemistry Laboratory, Product and Chemical Synthesis Laboratory. The Molecular Geochemistry Laboratory. Learning process of master degree. The teaching methodology in the MOC is conducted by various methods. The conventional explanation by the lecturer followed by the class discussion. The courses that adapt this method are thermal analysis.
Di thermal analysis nanti kita akan belajar tentang yang pertama nanti ada TGA seperti ini hitungannya gambarnya, kemudian ada TTA seperti yang di atas ini, kemudian yang di tengah ini adalah DSD, yang ini PMA dan yang bawah di sini adalah DMA.
Research methodology.
Lebih spesifik ya dibandingkan manfaat karena ada yang tidak tahu juga.
Membrane synthesis.
Yang paling mudah dibuat itu menggunakan inversi fase ini. Metode-metode yang lain ada, nanti kita akan bahas juga metode-metode yang lain, meskipun metode yang lain.
Natural Products Chemistry.
Gamanya yang dekat A ini alfa, yang di puncak atas itu beta di bawah, gamma di sini. Jadi gamma-gamma, dua gammanya. Dimetil, tadi siapa yang nanya ada dimetil dihidroksi, ini dua metil, dimetil.
Quantum Chemistry. For quantum chemistry, students are required to have the deep concept understanding and ability to derive several equations. The video showed that lecturer was direct the students to derive several equations and solve several problems. The study based on the recent article in the journal that has a relationship with the topic. The article-based study as an additional source explained by the lecturers. Discussion topic or presented by the students to develop concept and build the knowledge. Here is the courses that adapt this method. Structure and analysis of surface. The recent research on the application of structure and analysis of surface is studied based on the recent publication. For example, the study of scanning electron microscopy to identify a non-edible oil seed as energy corps. Molecular reaction dynamics. In addition, the explanation based on article-based study. The lecturer also give the assignment for student to study the article.
Telah disajikan 3 artikel mengenai spektroskopi Doppler, yaitu mengenai aplikasi terkini untuk mengamati perkembangan
Porous material.
Warna tekstil dihasilkan banyak oleh industri, di antara industri batik, industri tekstil, industri pewarna tekstil, dan industri produksi batik. Dimodifikasi dengan reos, kemudian dilakukan
Membrane synthesis.
Dimulai dari introduction overview dulu, yaitu teknologi membran yang muncul sebagai teknologi inti di bidang pemisahan. Teknologi membran juga diterapkan secara luas di berbagai bidang, terutama untuk pengolahan air, limbah, industri, farmasi, makanan, bioteknologi, serta lain-lain.
Develop students to have the ability in research design through the course micro project. In this course, student is required to design the research, how to conduct the experiment, then finally present their project. Before doing the research project of their thesis, students are required to present their thesis proposal. Here are the records of several thesis proposal.
Teknik poliol. Di antara berbagai metode yang ada, metode kopresipitasi merupakan metode yang paling sering digunakan.
Yang balik lagi ke ini ya, awal tentang urusan masalah ya, masalah ini tadi.
Namun, penjelasan terkait interaksi yang terjadi antara nikel yang didoping terhadap ZNO terhadap pewarna tersebut belum dijelaskan secara detail. Oleh karena itu, pada penelitian ini kami mengambil
good afternoon, everyone. Welcome back to parallel session. And now we have around nine presenter. The first is Ika Wulandari, and then second Daniel Pramudita. The third is Wiwi Dahani. Fourth, Jose Hernandez Santos. And then we have Agung Abadikis Wandono, Cininta Nareswari, Miftahul Jana, and the last Yudhistira Madani Putra Siahaan. Okay, I will give you the rule for this session. So you will present for 10 minutes and 5 minutes for Q&A. Okay? Okay, let's start for Ika Wulandari. Are you ready? Yes. Please come. Okay, for Ika, time is yours.
Okay, good afternoon everyone. Assalamualaikum warahmatullahi wabarakatuh. First of all, thank you for opportunity. Let me introduce myself. My name is Ika Wulandari. I'm an undergraduate chemistry student at ITS. Today, I want to tell you about fabrication of MEL 100 CR or pass mixed matrix membrane adsorber or MMMA for urea and creatinine removal in hemodialysis pen dialysis. With the outer team, me as Ika Wulandari from ITS and supervisor Prof. Nurul Wedastuti from ITS 2 and Prof. Witri Wahyu Lestari from UNS. The outline presentation begin in introduction, and next the methodology and result and discussion, and the finally is conclusion. This research is motivated by chronic kidney disease, which is increasing every year. It's estimated that by 2040, chronic kidney disease will be one of the leading cause of death in the world. One of the therapies required by chronic kidney disease patient is hemodialysis. As we know before, the need for clean water in hemodialysis is very much, and then byproduct also very much too. And so that for the processing of byproduct is needed. The byproduct is hemodialysis is called pen dialysis with various aromatic toxin in the table. And the main challenge of pen dialysis is separation of urea and creatinine because their small size and water solubility. Many methods are used in separating urea and creatinine, such as recirculation dialysis ready and wearable artificial kidney and electrooxidation method. However, looking at the efficient and economical can use method with adsorption and membrane method because the high performance is maintained from the absorption, and the membrane is because of flexibility and low energy. But in this research, we combining the absorption and membrane method to be MMA, the combining capacitance absorption with the filtration of the membrane, because the flexibility, low cost, and high selectivity. The material use of MMA in this research is PS, polyetherosulfone, because the high mechanical strength, excellent thermal behavior, and high chemical resistance, and use additive PVP from increase the membrane hydrophilicity and performer. So we used filler 2 as adsorbent, which is MEL 100 CR because the excellent thermal behavior and the superior absorption capacity. Next, the methodology. The G start with the dispersion of male 100 CR in NMP solution. Next, the insonicated for 1 hour, so at 1% PVP and 18% PS, and stirring for 24 hours and 60 Celsius. And next, degassing for 1 hour because they remove the bubble. And next, to fabricate the membrane with phase invasion and the module with flat sheet, which is the membrane that we fabricated before and characterized with FTIR, XRD, SAM, and so on. And the performance test, we use the two performance, which is water flow performance from the membrane method and the absorption performance with the absorption method. Next to the result. On FTIR, all membrane has a peak at wave number 1151 cm-1, which indicates symmetrical S double bond U stretching vibration, as well as wave number 1241 cm-1, which indicate asymmetrical S double bond stretching vibration. This peak is indicate of from the past polymer, and then a low intensity peak was found at the wave number 667 cm-1, indicating the presence of CRO bonds in M0.1 and M0.3 and M0.5 obtained from mil 100 CR material. And there is no peak safe in each membrane. It can be indicate there is no chemical bond between past polymer and mil 100 CR. And the next form XRD, the X-ray diffraction pattern of all membranes show broad peaks indicating a movable region of the polymer sample, which is polyether sulfone. And the peak possessed by all membrane correspond to the amorph peak of past polymer. The only difference is just the intensity of each membrane, which is the intensity you can affect the high and low produce the diffraction peak, which is the highest crystallinity with addition of mil 100 CR. Next, this is according with the increase in contact angle of the membrane. It can be seen in the graphic. Next, from the SAM, look in the figure. According for the SAM, the surface section show that there is small particle above in the surface membrane. It's indicate as mil 100 CR, but in the M0.3 and M0.4, just M0.5, there is the agglomeration because addition with too much filler. So in the cross section is show the asymmetric pore structure with different pore structure to the top and the bottom. And from the top is like finger-like, and in the bottom is like sponge-like. Is indicate just characteristic of past. So in the performance for water plugs and in M0.1. M0.1 is a very has a smallest water flux because increase line with a contact angle we discussed earlier. However, it's inversely proportional to the rejection produced by the M0.1 membrane, which is in flux urea. M0.1 have urea rejection for 38.63%, and on for creatinine, M0.1 have 47.29%. Next, from absorption for hormone used from the resulting absorption capacity, the contact time variation was carried out to see the optimum time. And for urea was generated from 1 hour, and from creatinine is in 3 hours. And in the result as in the table. So the result membrane rejection and option capacity are known. It can be seen that M0.1 has the most superior membrane in urea and creatinine rejection, but in urea absorption, M0.3 is still higher than M0.1 because there is agglomeration. So in the absorption capacity use M0.1 and the result is that in the line. So this research conclusion for this study considered the importance of combining filtration and membrane absorption process in the effective removal of urea and creatinine. MMMA exhibited significant ability in urea removal, which is 38.63%, and creatinine removal 47.29%. And MMA showed absorption capacity of urea up to 20.75 milligram per gram, and absorption capacity of creatinine up to 1.156 milligram per gram. So that's all for me. Thank you for attention.
Okay, thank you so much for Ika. We have 5 minutes for Q&A. Is there any question? No? Okay, maybe, okay, please.
I'm wondering, sorry, by the way, my name is Daniel. I am quite interested in the fact that you chose to have like a combination of membrane and also adsorbent, because the main problem when it comes to membrane is about the falling, right? So at the same time, you introduce a mechanism that actually promotes falling. Perhaps you didn't show it, but do you have like a preliminary result of the performance or also the duration of the use duration of your products? So that means perhaps there is a shorter time due to the falling, but still acceptable or something like that.
Okay, please.
Maybe that's my fault because I can't show in this presentation, but on the falling membrane, it's absolutely in there is in the membrane, but because I use mil 100 CR, there is a pore what is that pore this is the material that have superior pore. So urea that's
Can be
it can be collected in the pore of mil 100 CR, but because the cross flow from the membrane, urea can be
moved into the pore,
can be solid to the retentat. So maybe in my opinion, that's not maybe the bond with urea or creatinine is not. It just like a collect in the pore, just physically. So if the solution in the like in the membrane is just like a cross flow. So after if the feed membrane in the if the feed membranes in start, there is a result in permeate and retentat, and the urea and creatinine is maximal separate in the retentat.
Is it clear? Or Do you want to ask about falling? Falling. How about the falling for the membrane? How to remove the falling, right? Or
Yes, because I'm expecting like a higher rate of falling.
Yeah.
Because you have absorption, right? You have absorption, so most likely there will be higher rates of falling, except you are using a membrane with larger pore size.
Your pore is so large, so maybe it can make a falling. So how to remove or manage this falling into your membrane?
It maybe just like absorption, like a desorption, and
What do you want to say? Desorption. Desorption. Okay. Yeah. So
with desorption time, desorption and the permeate as a feed, but and feed as a permeate like this.
Yeah, perhaps we can discuss about it later.
Maybe it can be discussed.
After that, it's really interesting at the time.
Yeah, maybe you can discuss later with the speakers. Okay, we still have a time? Okay, don't have it. Okay, thank you so much for Ika for a nice presentation. We move to the second speakers. He is Daniel Pramudita. Okay, time is yours.
Okay, while waiting, I really meant to ask. I mean, not to reduce my nerve. Okay, anyway, thank you and good afternoon, everyone. So my name is Daniel Pramudita. I'm on behalf of our research group. I came here to give a short story about part of our research, which is actually about utilization of palm trunk as a growth medium of black soldier fly larvae. But for this event, we only present some part of our research. As you can see here, as suggested by the title, it's about the fungal fermentation of palm oil trunk fibers with the focus on the content of protein and also CN ratio. Okay, yeah, we are talking about palm oil. It is becoming more and more popular recently, especially since the introduction and also involvement of the BPDPKS. By the way, the research is also funded by BPDPKS. And it is very famous, I mean the plant, because you can basically make like many things out of it. And here we have 5 Fs, like food products, pharmacy, feedstuffs, fuels, and even fibers. In our university, there are many groups, especially in the chemical engineering department, working in the utilization of palm oil. And I think recently in ITS also a lot of lecturers got some research funding. So it's quite interesting and also quite hot topics, I think, to talk about. Here you can see all the utilization. I don't want to talk too much about it. So current state of Indonesian palm oil, even though we are still the biggest palm oil producer in the world, actually we are having a problem of reducing productivity. And because of that, the government has announced a plan to do replanting. So the old plants will be removed and new plants will be introduced to the plantation. And this might potentially cause a problem because that means we will have a lot of trunk, okay, in the plantation as waste. And the trunk itself is actually a big part of the palm oil plant, which is about 91% in mass. Okay, so, and we can also imagine that with the large number of plantation area in Indonesia, especially concentrated in these 2 islands, in Kalimantan and also in Sumatra, we can expect a lot of problem here. So the next question is, how are we going to use the waste? how are we going to use the to utilize the palm trunk. Okay. Sorry. Yeah. With the current state, the target of replanting is about 180,000 hectares per year, which if we convert it with the planting density of 140 plants per hectare, that means you will have about 19.7 million tons of waste per year. Okay. Currently, our partner in Unila, University of Lampung, is working on extraction of sap of the palm oil trunk for bioethanol production. But this also do not fully alleviate the problem, because after the sap is extracted from the palm oil trunk, we will still have plenty of biomass left. Okay, so this is basically the process of sap extraction. We have the oil palm trunk, and then, okay, after some processing, then we'll have the sap, and we still have the dregs, or the remaining fibers out of it. Okay, and we want to use this drag basically because it is still rich in lignocellulose, and to some extent it still has some sugars inside of it. Okay. And one of the potential use is to use it as a growth medium and nutrient source for the black soldier fly larvae, which is a source protein for animal fodder. Yeah. The main goal of this whole project is actually to make like a substitute for animal fodder, so that we can reduce the amount, perhaps just small amount, but quite meaningful amount of import for the animal fodder, because right now we are our friends in the animal husbandry still have this kind of problem. Okay, so the idea is to use fermentation process to convert lignocellulose into sugar and increase the overall nutrition content of the BSF larva. Okay, so that's the idea of our research. Perhaps some explanation. How many more minutes do I have? How many more minutes? Okay, perhaps some explanation. This is the larvae, just to introduce you how it looks like. But again, we are not going to talk too much about it. So this is the research steps that we are currently doing. So from the palm oil trunk, then we will have the sap removed, okay? And then we conduct characterization of the dry drag, and then we do fermentation. And after that, we characterize the fermented drag before we fed it into for the BSF. And this three part is actually the scope of this current research. Okay, we are not talking about the previous and also the later part. So here in this presentation, I limit the scope of this presentation. We are only talking about the protein content. Yeah, because many aspects to talk about, but protein content is particularly interesting because no matter what, in the end, we would like to produce like source of protein in the shape of BSF larvae. So the question is, even though we can process the OPT dregs, how about the protein? How will it change? That's the question. Okay, and here we explore on the fermentation temperature and also time of and their influence on the protein content during the fermentation. And basically the last question is, from the protein content perspective, can this process of fungal fermentation give the fermented OPT dregs, quite good enough as the growth medium for BSF? This is the material that we use. This dried dregs is actually the remaining of the drag that has been extracted. I mean, the sap has been removed, and this is supplied by our partner in the Unila. We store it in a refrigerated temperature, and after that we analyze to get the content of this material. Okay, the next step, the important step is to prepare the fungi, and then we first try to cultivate the fungi on agar media before moving it into liquid medium, and then after that after some 5 days inoculation, then we put it on the rice. After some days, the rice will get dry, and after that, we make the rice into powder before we extract the spore from the rice by using a Kirk's medium. And after the Kirk's medium, the extracted spores have been prepared, then we wet the OPT dregs with the liquid with a certain solid liquid fraction ratio, and also with certain density of spores. After that, we do some variation of temperature and also time, and before then and after the process, we also characterize the materials. Okay, so to give some illustration, these are the pictures of the dregs that have been fermented. So as we can see here, this is before fermentation for the dregs before fermentation, and then after fermentation for different days and also different temperatures. For 2 different fungi, then we get a difference in colors, and there will be explanation about that. So this is the result for protein content. What we can understand here is that during the first days of fermentation, we will have some reduction in protein content, and this is because the metabolism of the fungi will need protein as the source of energy, and however, in the end, Aspergillus oryzae gave more protein content than Aspergillus niger in the final fermented products all across variation. Okay, so we can conclude that this fungus is better when it comes to retaining protein content. And we also understand here that after 7 days of fermentation, usually it either decrease the protein content or creates no significant difference. And as I told you, it's because of the enzyme protease that hydrolyzes peptide bonds into amino acid. But after 7 days, we will have some increase. Okay. After 7 days after another 7 days at room temperature, that means after 14 days, we have another decrease. But when the temperatures increase to 37 Celsius, which is the optimum temperature for the fermentation, we can see that the protein content actually increases, and we attributed it due to the possible shifting of fungal growth curve, which reduces the protease activity. And the result here also in correlation with the CN ratio, as we expect that if we have larger protein content, then we will have smaller CN ratio. So the fermentation by Aspergillus oryzae resulted in much lower CN ratio compared to Aspergillus niger as expected. And this range of value is actually, at the end, is actually bigger than those required for BSF, but still acceptable according to some studies. Okay, and this CN ratio reduction will translate to waste reduction index of 25 to 34%, which is also quite acceptable. So the conclusion of our study, the first conclusion is that both fungi significantly influence the fermentation when it comes to protein content and CN ratio. And for the process, we recommend the use of Aspergillus oryzae for the further use as for producing growth medium of BSF larvae. And basically, when we have ideal growth temperature, fermentation temperature, we only need 7 days. But when the temperature is actually quite low, when it, for example, like at room temperature, we need longer fermentation time for that. And that concludes my presentation. And we also acknowledge the funding from BPDPKS. Thank you very much.
Okay. Thank you very much for Daniel. Okay, now we have 3 minutes for Q&A. Is there any question? Okay, no. maybe I want to ask you. So you use the fungal, right? The
fungi, yes.
Yes. Why you use the fungal for this fermentation process?
Why use the two fungi? Yes. You mean the selection of the fungi? Yeah, because these two are among the most commonly used and also quite easy to cultivate. That was the reason why we chose these two. Actually, we are still exploring other possibilities. For example, like while here we only presented the result from these two fungi, but we are also conducting other experiments using other fungi and also other materials for fermentation.
Okay.
Okay. So basically, why we chose this first because of its common use. Nothing else.
Okay. And I just wonder why. How if we need more time for you said that after 40 days the protein will be reduced, right? After 40 days. After
14 days.
Yes. This one. After 40 days the protein content will be reduced. So if we make a long time more than 40 days, what's happened?
Well, we usually do not recommend longer time than 14 days. So what I meant longer is you first either conduct it for 7 days or you make it longer up to 14 days. Because normally people only do it for maximum of 14 days or 10 to 14 days. Okay, so we do not recommend doing it for more than 14 days. That's the reason. And by the way, another reason why we chose these two fungi is because they have protein conversion capability as well.
Okay. I see. Okay, times is up. Okay, thank you so much for Daniel.
Thank you.
Please give applause. Okay, next to the move presenter, Wiwi Dahani. Okay, are you ready? The slide, please. Okay. For Wiwi, times is yours.
Good afternoon, everyone. Thank you, Mrs. Kartika, for the opportunity. My name is Amalia Sidaningse. Representing Mrs. Wiwi Dahani will present the research entitled Separation of Cerium and Neodymium from tin tiling with fermentation using activated carbon palmitic acid as collector. Okay. Most of worldwide supply and production of rare earth metal is currently dominated by 4 countries. China contributes about 16% of the total global production, followed by United States at about 16%, Burma at about 9%, and Australia at about 8%. The increasing demand for rare earth metal is proportional to the ore quality degradation, so the potential resources are needed to supplement the current supply stock. Potential resources come from low-grade ores, tiling of mining, unconventional resources that can use exploited for rare earth metal beneficiation. Evaluation of mine tiling as a potential resources for rare earth metal utilization has attracted considerable attention in the last 2 decades. One of the most utilized mine tiling is tin tiling. Tin tiling is a tin ore mining and processing waste. According to the 2017 study of potentially associated mineral, tin tiling contains ilmenite, monazite, and zircon. The advantage of tin tiling contain a variety of strategic mineral that can be refined into metal with high economic value, potentially use a raw material for construction materials and geopolymers, and generate financial benefits, reduce consumption of natural resources, and reduce waste generation. The material used in this research is froth flotation method. Froth flotation is utilized the difference in hydrophobicity of mineral surface. The hydrophobic mineral particles will submerge and hydrophobic will adhere to air bubbles and rise on the surface. The froth flotation method has a advantage. There is a high selectivity in separating rare earth metal, economical, environmental friendly, and minimally toxic. In the flotation process, the use of collector is important because they contribute to changing the surface properties of minerals. In general, fatty acid such as palmitic acid can be used as a collector in for flotation in separating rare earth metal from tin tiling. The selection of palmitic acid because it is a water insoluble long chain saturated fatty acid with a solubility of 0.05 mg per liter at 25 degrees Celsius, eco-friendly, heteropolar organic mineral that contain more non-polar groups than polar group have greater hydrophobicity. However, the use of palmitic acid as a collector has the disadvantage. There is a lack of selectivity for separating rare earth metal sulfide minerals. Therefore, it is necessary to add activated carbon as an adsorbent to palmitic acid to improve collector performance and selectivity in separating rare earth metals. Based on the background description, the following problem statement is contained. First, the weakness of palmitic acid as a collector. It is necessary to add activated carbon to palmitic acid to increase the selectivity of separation of rare earth metal in the mineral form of cerium phosphate and indium phosphate. The second, comparison of activated carbon palmitic acid composites. Optimal ratio of activated carbon palmitic acid as a collector for the separation of rare earth metal in the mineral form of cerium phosphate and indium phosphate. Next, experimental. The experimental in this research include materials, procedures, and characterization. The material used in this research are tin tiling from PT Timah Tipika, bambu carbon, sodium hydroxide, hydrochloric acid, and palmitic acid. The procedure performed include bambu carbon activation, impregnation of VCPA composite, and flotation. And the characterization performed include XRF, XRD, SEM, absorption of nitrogen, and FTIR. The first procedure is bambu carbon activation using chemical activation. The pyrolyzed bamboo carbon was crushed and sieved to 120 mass, then weighed and soaked in 0.1 molar sodium hydroxide at 85 degrees Celsius for 3 hours to remove organic substance contained in the carbon and open carbon pores. Then the immersion solution was filtered and dried at 105 degrees Celsius for 2 hours. Then the mass residue was weighed and soaked in 0.5 molar hydrochloric acid at 60 degrees Celsius for 3 hours to remove the metal impurities. And then the result was filtered and distilled in hot distilled water, then dried and calcined to resolve the activated carbon. The activated carbon was characterized using SEM and PET. The second procedure is impregnation of VCPA composite. The activated carbon was dried at 70 degrees Celsius for 6 hours, then put into beaker with the different mass ratio. Then the composite was dried at 70 degrees Celsius for 24 hours and stirred every 8 hours. Then cooled at the room temperature. And the SCPA composite was analyzed with FTIR. Third, the fourth flotation process. Before fourth flotation, tin tiling was characterized using XRD and XRF. Then the fourth flotation process using simple laboratory scale flotation device. The first contacted between tin tiling and SCPA composite in a ratio 50/50, then add still water little by little until palm formed, and put aerator into the palm, then flotation for 2 hours. Then the fourth was dried and calcined to decompose the carbon. Then the flotation product was characterized using SRF and XRD. And next, the result and discussion. The first is XRF of tin tiling. Based on the data in the table, The highest percentage of metal contained in the tin tiling is cerium at 23.9%, followed by iron, neodymium, titanium, phosphate, tin, and silicon. Then the other 28.58% are the other metal with a very small percentage. Next is XRD of tin tiling. Based on the diffractor count of tin of tiling, the most diffraction peaks are shown in the mineral is cerium phosphate and neodymium phosphate, which produce diffraction peaks following research by Anita et al. And the contained mineral cerium phosphate and neodymium phosphate are contained in tin tiling is 14.08% and 12.72%. This is the same bamboo activated carbon. This picture shows the surface morphology of bamboo activated carbon at 500 times magnitude, and this picture shows the 5,000 times magnitude shows like bamboo fiber, and this picture shows the 10,000 times magnitude shows that the activated carbon are open and there are still tiny particle of bamboo. The bamboo activated carbon was characterized using dissociation of nitrogen to determine the surface area and pore size using PGH and PET method. The surface area of bamboo activated carbon was 534.280 meter square per gram, and the total volume is 0.247 centimeter cubic per gram. Based on the absorption-desorption isotherm curve, bamboo activated carbon has a type 1 isotherm pattern. Based on the pore size distribution analysis, bamboo activated carbon has a pore size of 3.2 nanometer, which is a micropore size. This is a FTIR of ACPA composite. As you can see, the spectrum of ACPA 100 or pure activated carbon shows has a significant absorption peak at wave number 1570. Then the spectrum of pure palmitic acid has 6 absorption peaks, and the other ACPA composite shows has 6 absorption peak, same as pure activated palmitic acid. Comparing the FTIR spectra of activated carbon with the ACPA composite, there are no new peaks formed in the ACPA composite spectrum. This is indicated no chemical interaction between activated carbon and palmitic acid, but only physical absorption. The fourth of calcination result. This picture shows a fourth of calcination. The carbon is the composite successfully decomposed, leaving a slightly reddish orange powder. The next of XRF of fourth of calcination result. Based on the data, the highest percentage content of rare earth element contained in the calcined fourth was cerium at 6.22% and neodymium at 1.8% obtained from fourth flotation with an ACPA composite ratio of 25/75. Then the separation of rare earth metal with pure activated carbon collector or ACPA 100 composite contains cerium and neodymium, which is higher than the separation result with pure palmitic acid collector. Then this is the XRD fourth of calcination result. Based on the diffraction, the fourth of calcination result produce diffraction peaks of mineral monosite cerium, cerium phosphate, monosite neodymium, neodymium phosphate, hematite, cristobalite, with the 2 theta is below. The diffraction angle shows are the same for all 5 diffraction, indicating the same mineral crystal phase. The mineral data of fourth of calcination result shows in the table. Based on the table, the large percentage of cerium phosphate and neodymium phosphate minerals contained in the calcined fourth were cerium phosphate at 10.43% and the neodymium phosphate at 2.98%, obtained from fourth flotation with an ACPA composite of 25/75. Then the percent of cerium and neodymium phosphate minerals contained in the calcinate from separation with pure activated carbon collector is higher than the pure palmitic acid collector. The percentage of mineral contained cerium phosphate and neodymium phosphate obtained after flotation is smaller than cerium and neodymium obtained before flotation, because the flotation process with SPA composite doesn't use a filter agent, so the fruit produced is small and unstable and result in many minerals immersing in the bottom. The last conclusion, based on the research that has been carried out, it can be concluded that the addition of activated carbon to palmitic acid can separate the metal in the form of mineral cerium phosphate and neodymium phosphate from tin tiling at 10.40% and 2.98% with an SPA composite ratio of 25/75. The SPA 100 composite pure carbon can separate rare metal in the form of mineral cerium phosphate and neodymium phosphate from tin tiling at 28.18% and 8.47%. The SPA composite 100 composite or palmitic acid can separate earth metal in the form of mineral cerium phosphate and neodymium phosphate from tin tiling at 6.2% and 1.34%. The three of them are still less selective in separating earth metal in the form of mineral cerium phosphate and neodymium phosphate from tin tiling. Further testing need to be carried out regarding variation in the mass size of tin tiling samples. That's all my presentation. Thank you very much.
Okay, thank you so much, Miss Wiwi. 2 minutes for Q&A. Do you have a question? No? Oh yeah, please.
Thank you for the opportunity. I'm Devanophilia. I just wondered that you use the activated carbon from bamboo, that then the others as an adsorbent. Can you tell us the reasons about that, and is there any raw materials that can use as adsorbent of the rare earth element? Thank you.
Thank you for the question. The reason as I use bamboo carbon as a adsorbent in this research is because bamboo is abundant and the price is cheap compared to the carbon from other materials. So bamboo was chosen as the carbon materials. We can use carbon from other materials such as shell, ketamurung kelapa to this research, but will produce different characterization such as pore size.
Okay, so different raw material will be different characterization. Okay, it's okay. Okay, I think time is up. So give applause once again for Miss Wiwi. Okay. We move to the next speaker, Jose Hernandez Santos, with the title Optimization of Methylene Blue Dye Removal by Flocculation using Response Surface Methodology. Okay. Okay, for Jose, time is yours.
Thank you very much. Good afternoon, everyone. I actually feel young today because most speakers are research students and I look like a professor. Actually, I'm presenting this on behalf of my student because I have a confession to make. I use this paper as an excuse to visit Bali. So these are actually a final year project from my student in Brunei. And I think I'm the only representative from Brunei. My name is Jose Hernandez Santos, although I'm not originally from Brunei. I'm from the Philippines. You see from my name, it's actually a Filipino name. So today, I'm going to talk about optimization of methylene blue dye removal by electroflocculation using response surface methodology. Okay, so let me start with electroflocculation. What is electroflocculation? It's a water treatment method that uses electrical current to aggregate the contaminant, making them easier to remove. And the mechanism involves a metal which is being oxidized, and that metal initiates the formation of flocks. And then once the flock is formed, we can actually separate them through flotation or sedimentation. And the advantage of this method is it's efficient, chemical-free, we don't add any chemicals, and it's eco-friendly. So this is the electroflocculation cell. As you can see, we have plates here. These are the anodes and the cathodes, and the wastewater is the electrodes are actually immersed in the wastewater. And what happens here is when we apply electricity, the metal is oxidized, and that metal produce M3 plus or whatever oxidation product are there. And in the cathode, water is reduced to produce hydrogen and hydroxide. And this metal combines with the hydroxide to form the metal hydroxide, which initiates the flux formation. So the model system I'm going to report this afternoon is pollutant with methylene blue. So the target pollutant is methylene blue, and the electrodes are aluminum for both anode and the cathode. And the factors that we can vary to optimize are applied voltage, electrolysis time, electrolyte concentration, initial dye concentration, and number of plates. And of course, the response would be the color removal efficiency. So the main objective of this project is to maximize the color removal efficiency while considering the time and cost of the electroflocculation process. So there are two approaches to optimization. The first one is the commonest. We always do this. That is one factor at a time approach. In this approach, the OFAT examines one factor at a time while holding the others constant. So if you have 5 factors, all the 4 factors are kept constant, and you change the 5th one. And then you do the same with the 2nd, the 3rd, and 4th. So this is straightforward to implement, but the problem here is because you're only changing one parameter, then you overlook the interactions among the factors. And this is time consuming because it requires a large number of experiments, especially with many factors. Now the other approach is response surface methodology, and this morning somebody reported similar to this one. And RSM optimizes process by modeling the relationship between variables and responses with fewer experiments than OFAT. So it uses statistical and mathematical approach to optimize the process. So it uses polynomial models and experimental designs to capture interactions and quadratic effects. So we are not limited to just a single effect. And RSM provides efficient insights into the complex system, aiding in effective process optimization. So these are some of the preliminary tests that we got using the OFAT approach. So as you can see, obviously, if you increase the voltage, you have better removal. If you have longer electroflocculation time, you have better removal as well, and so on. But based on our study, the most effective parameter are the applied voltage, electroflocculation time, and number of plates. So we focus on these 3 factors, the number of plates, applied voltage, and electroflocculation time in doing the response surface methodology. And the software that we use is Design Expert version 12. The one this morning used Design Expert version 13. And the original encoded factors are the number of plates, which is the A, applied voltage, B, electroflocculation time, which is C. And the levels would be the low level for number of plates is 2, the high level is 6. And the applied voltage is from 10 to 20. Electroflocculation time is from 20 to 60. So if you're doing a one factor at a time optimization, what you do is you keep the applied voltage and the electroflocculation time constant while you are varying the number of plates. But with RSM, we don't do things, we do things differently. And at the same time, the RSM considers not only the direct effects, which are for A, B, and C, but also the interactions among the factors. So this is AB, AC, and BC. And on top of that, we also consider the quadratic effects, A square, B square, and C square. So at the end, we have an equation involving A, B, C, AB, AC, BC, and A square, B square, and C square. And of course, the response is color removal efficiency. And if you are not familiar with Design Expert or any oops, 5 minutes left, any RSM software, what you do is you just input all the 3 parameters and it provides you with the experimental design. So what we do is the RSM gives the 17 experiments, and the first experiment would include 2 plates, 20 volt and 40 minutes electroflocculation time. And so you just perform all these 17 experiments, and at the end of each experiment you input here the color removal efficiency. And then at the end, RSM would actually provide you with the results. So these are the ANOVA results for the quadratic model. And as you can see, the p-value here, if the values are less than 0.05, they are significant. And so for the quadratic model, it's actually significant. But if you can analyze the quadratic effects, a square, b square, c square, the p-values are higher than 0.05. That means they are not significant. And so we ended up removing the quadratic effects. And so we have the 2-factor interaction model, excluding the a square, b square, and c square. And you can see all are significant, including the lack of fit. So to make the long story short, the model that fits is the 2-factor interaction model. And so the equation would look like this. So these are the coefficient estimate from the software. So if you're familiar with the equation of the best fit line, y equals mx plus b. So when you are doing this RSM, you end up with a model equation like y equals 80.54 plus 9.29a, blah, 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 all right? And this is based on the coefficient estimate from the software. And so we performed the calculation and compare that with the actual experimental results, and we have this really good fit between the predicted and the actual results. And to verify the optimum conditions suggested by the software, we also perform experiment and compare that with the calculated by the model. And so we have this percentage removal, experimental and predicted, and the software predicted that the optimum values for the factors would be 6 plates, 19.29 applied voltage, and electroflocculation time of 20 minutes. And finally, these are the conclusions. And I don't think I have to explain them because I have already told them about it. I have no more time. Thank you so much.
Okay, thank you so much, Mr. Jose. Okay, we have 3 minutes for Q&A. Do you have question? Okay, Prof. Hamza,
oh,
please.
There's a professor here.
Okay, it's very interesting, and also I've learned about the responsiveness methods. I heard these methods quite a lot in my university, but with your explanation, I understand more. Yeah. My question is about the number of plates, and then the result here showing that 6. The 6 is the maximum number that you use. Is there any possibility that if we add more and you will get better? Thank you.
Yeah, actually we experimented with number of plates, and of course the minimum number of plates would be 2. You have 1 anode and 1 cathode, and then this would be even numbers because we have equal number of anode and cathode. But the limitation with more number of plates is the space area wherein you can contain all those electrons. But definitely experimental results confirmed that the more plates, the higher the removal efficiency. But that means you need to buy more plates, and so in terms of economic value, that is not really cost effective, because if you have fewer plates and then you just make it longer, then you don't have to buy a lot of plates. Yeah. But definitely more plates results to higher efficiency.
Involving the economics or with the price for the efficient number of plates. Maybe that is the next thing that.
Yeah, I understand what you mean. Actually, we are moving towards that direction in the more bigger scale. But the reason why we have a maximum of 6 is because of the capacity of our cell. We can only include a maximum of 6 plates. That's why that's our limitation. So our optimization includes only up to 6 plates. Thank you, Professor.
Maybe for the next study, Mr.
Yeah, we are into that.
Yeah. Okay, 1 minute. Yes, please.
Yes, thank you, sir, for the nice presentation. So my name is Giovanni, and I don't know if I skip your presentation, but I believe you haven't said the concentration, initial concentration of methylene blue that you use. Is it affecting, so is the initial concentration affecting the efficiency of the electrophocalization?
Yes, we have some preliminary experiments, and we thought the result is the lower the concentration, the initial concentration, the higher is the efficiency. Because when you have higher concentration of methylene blue, then you have a lot of work to do. And so we fixed it to 20 ppm, 20 milligrams per liter. But we didn't include that in the optimization because we can actually make it lower. Yeah.
Okay, it's okay. Okay, time is up. Thank
Okay,
you
thank
so
you.
much for Mr. Jose. Very interesting study. Okay, we move to the next speaker. Agung Abadi Kiswandono. Agung, Mr. Agung. Okay, no. Okay, si Cininta Nareswari. Yes. Okay, please. The slide, please. Okay, Cininta, times is yours.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Now I want to present our research by the title is Performance Photocatalytic Degradation of Methylene Blue Diols from Aqueous Solution ZNO Graphite Carbonitride Composite. And our team research are Professor Safril Aklus and me, Cininta Nareswari, Dwi Prasetyo, and Dr. Trianda Gunawan from Department of Chemistry, Institut Teknologi 10 November. From the global textile dyes market was valued at USD 10.60 billion in 2021 and expected to grow until 2030. From the 700,000 tons synthetic dyes produced per annum, but 10 until 50% delay release into environment. The kind of the dye release into environment, such as methylene blue. Methylene blue is dangerous organic pollutant because stability at room temperature and highly toxicity. The one method can be used is photocatalytic. The advantage of photocatalytic eco-friendly, simplicity, inexpensive, no toxicity byproduct. Reaction take place at ambient temperature, but depends on the light source. Considering to the condition in Indonesia, UV index 2040 Indonesia report by BMKG has ranked UV, and so Indonesia not only the visible light, but also influence UV index. So for the photocatalytic materials, use can catalytic active in UV and visible light. The one material can be used ZNO because environmental friendly and strong ability photocatalytic energy under UV light, but ZNO cannot be active by visible light. And others materials can be used graphite carbonitride because active under visible light. So ZNO and graphite carbonitride can composite, and we hope active photocatalytic reaction under visible light and active photocatalytic reaction under UV light. And the next for the methodology, the first for synthesis of ZNO graphite carbonitride composite, urea, the water and zinc nitrate hexanhydran dissolve 30 minutes and then dry to remove the water, and then for calcination, and we got the ZNO graphite carbonitride. And the next for catalytic test, we use two sources of lamp, UV or daylight lamp. And the next for the characterization, using XRD. In the 002 plane indicated the stocking of graphitic and the intensity of 002 plan decrease indicated that CNO destroyed the nitrate pore structure. And the next for the 100 plan is attributed to the planar structure of gravity carbon nitrate. The absence of the 100 indicated that CNO destroyed the nitrate pore structure. But for the ZN confirmed by SEM ADX is positioned between the CNN element. And the next for the performance catalytic, we use the under UV light and under daylight. The longer exposure time, the result in higher methyl blue removal percentage. The highest methyl blue degradation percentage under UV light for 24 hours was CNO gravity carbon nitrate composite, and gravity carbon. The highest methylene blue degradation percentage under daylight for 24 hours was CNO gravity carbon nitrate, and the next gravity carbon nitrate, and the last CNO. If you use UVV spectroscopy of methylene blue before and after photocatalysis for 24 hours, so it changes indicated the photocatalytic process, and after 24 hours, colors of methylene blue is more clear. And the reaction of photocatalytic, the first gravity carbon nitrate absorbs invisible light exciting electron from the valence band to the conduction band, creating hole in the valence band. Second, electron from gravity carbon nitrate migrate to the conduction band of CNO, reduction electron-hole recombination. And third, electron in CNO reduce oxygen to form superoxide radical. And the fourth hole in the gravity carbon nitrate oxidize water to form hydroxyl radicals. And the last, the highly reactive superoxide radical and hydroxyl radical decompose pollutant into other safer product. And the last for the conclusion, for the synthesis, the CNO gravity carbon nitrate composite was successfully synthesized and confirmed by XRD and SEM. And the last for the photocatalytic performance, the longer duration correlated with higher degradation percentage until 24 hours. And the CNO gravity carbon nitrate composite photocatalytic performance is effectively under UV and daylight, 95.46% and 96.27% respectively. And the last, thank you for the Department of Chemistry and Fuels Chemistry Laboratory, and also my supervisor Dr. Trianda Gunawan and Professor Safri Akul. Thank you for attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you so much. Oh, we have a lot Q&A, a lot time of Q&A. We have 8 minutes for Q&A. Is there any question? Yes, please.
Thank you for opportunity. I saw the slide in perform photocatalytic. Can you slideshow? I compared the graphic in under UV light and UV light and daylight, and I saw that for material in graphite carbon nitrate is more active for photocatalytic than zinc oxide. What is the reason?
Okay. Why is CNO more active in UVVs and graphite carbon nitrate active in daylight? It's because if CNO have a band gap more higher than graphite carbon nitrate, around 3 electron volt, but graphite carbon nitrate have band gap around 2.7 electron volt. So CNO need more higher energy to reaction with methylene blue than graphite carbon nitrate under UV light. But we use daylight. The energy of daylight more lower than than UV light. So graphite carbonitrate more active under UV under daylight than ZNO.
Is it clear? Okay, clear. Okay.
Yeah, thank you. Think if we put together research on methylene blue, maybe we can have the special session for methylene
Special
blue.
issue.
Yeah. For this case, I'm like asking to ask one question. In working with methylene blue using membranes, there are two events actually occurs. First is separations by pore. The second is absorptions by the membrane materials. How did you separate these ones, or so it show you the separations sites, not absorption, or maybe this results is the sums of separations as well as the absorptions. So maybe you can tell us about this one. One of the indicator is whether your membranes after being used as the membranes is becoming blue. And it's not because of the what's called fallings, but it's because the methylene blue is absorbed. Thank you.
Please.
Thank you for question, Prof. Hamzah. And the first, for our research, for this research, not membrane but catalyst. For the catalytic, for the method, first absorption first, and then for the next step, photocatalytic. So to remove all the absorption reaction, and then for the next step is photocatalytic. So after 24 hours, if we show in UV spectroscopy, the spectra of methylene blue after 24 hours change, then methylene blue, so indicated that photocatalytic process.
So this is photocatalytic, not absorption process.
Yes, it's photo.
No absorption. Okay. Okay, still have time? 2 minutes. 2 minutes. Do you have a question? Yeah. Maybe I want to continue with question of Professor Hamzah. I just wonder if we do the time longer than 24 hours, the methylene blue can be all degradation or not?
I think it's degradation because if we do for the UV spectroscopy, for the methylene blue have the maximum maximum wavelength in 664 nanometer, but after 24 hours more lower than methylene blue, so indicated that change others product in methylene.
So the removal percentage of removal will be higher or lower?
The percentage of removal more higher every higher time.
Is there any limitation of we can decompose it for degradation the methylene blue? Limitation time?
Limited time. I think it's not limiting time because after 24 hours, more higher removal every contact time with catalyst.
Okay, Okay, times is up. Thank you so much for Miss Sininta. Please give applause. Okay, next, Miss Miftahul Jannah. Okay. The title is Synthesis of MCM41 double ligand as heterogeneous photophantom catalyst for degradation of methyl orange. Okay, times is yours.
Okay, good afternoon everyone. My name is Miftahul Jannah. I'm from Department of Chemistry, Institute Technology 10 November, and I'm delighted to be here to present synthesis of MCM41 double ligand FAZR MOF composite as heterogeneous photophantom catalyst for degradation of methyl orange. In this presentation, there are 5 highlights, including introduction, research methodology, material characterization result, photophantom activity, and finally conclusion. Clean water is basic need for the survival and growth of all living things. However, rapid urbanization, industrialization, population growth, and the presence of power plants have reduced in clean water. One of the major environment pollutants that pose a risk to humans and the environment is the waste from industries such as textile, pharmaceutical, or paper manufacturing. There are approximately 1,100 dyes in worldwide, of which the most commonly used dyes is azo dyes. Methyl orange is a non-ionic azo dyes which is stable against in light and temperature. Methyl orange has an aromatic structure, and which is causes it to be mutagenic and carcinogenic. And then this is the application to degrade methyl orange. I choose phantom. Phantom oxidation is one of the most cost-effective advanced oxidation process techniques that use a chain reaction between Fa2+ and hydrogen peroxide to form hydroxyl radicals. But phantom has several shortcomings, such causes iron deposit and a limited pH range. To overcome this problem, the AOP, or Advanced Oxidation Process, and the AOP method can be combined with the photophantom process. Photophantom is oxidation reaction that takes place under visible or ultraviolet irradiation using a phantom catalyst. Compared with the phantom method and UV hydrogen peroxide system, the photophantom method has the advantage that it can increase the Fa2+ reduction. And then double ligand MOF. I choose double ligand MOF with MOF synthesis via replacement of one linker with a derivative containing substituents in the aromatic ring, resulting in the formation of an isostructural lattice. With double ligand MOF, we can get MOF stability increase, systematic pore connection, and increased functionality. And we use terephthalic acid and 2 amino terephthalic acid as a ligand.
To improve performance of MOF-based catalysts, we use bimetal MOF with excellent synergistic effect between different metals, structure stability improvement, and increased regeneration. And we use iron and zirconium-based MOF. And we also add mesoporous silica, MCM41, which can improve the interaction between metal and support and stabilize the physical structure of the catalyst. Okay, next research methodology. There are four steps. One, synthesis of zircon MOF double ligand or mix L. Synthesis of UIO or zirconium MOF with linker modification with terephthalic acid and 2-amino terephthalic acid. And synthesis of MCM41 zircon MOF double ligand with addition MCM41 is 25%. And 3, synthesis of MCM41 FAZR MOF double ligand with variation in iron addition is 10, 20, and 15%. And then last, photophantom test on methyl orange dye in water. Okay, this is the illustration of synthesis of zircon MOF double ligand. Zirconium chloride was dissolved in DMF in 15 minutes for metal solution, and for the ligand solution we use double ligand and was dissolved in DMF and stir in 15 minutes, and then two solution is mixed and add acetic acid and then stir again in 13 minutes, and then sulfur-thermal process at 120 Celsius for 24 hours, and then wash with DMF and methanol and dry in the oven at 90 Celsius. And then this is the illustration of synthesis MCM41 FAZR MOF double ligand with addition MCM and iron in metal solution. And this is the result, the factogram of synthesis materials. The characteristic peak of ZR MOF or UIO66 was observed at 2 theta of 7.2 degrees with high intensity and 8.3 degrees with moderate intensity. All samples exhibited the characteristic UIO peak, indicating that the introduction of iron did not cause structure damage to UIO66 after the introduction of iron species. And the crystallinity of the synthesis material gradually decreased with increasing iron content, and no Fa oxidation peak was detected. And this is FTIR spectra of synthesis materials. In the U mix L or UIO double ligand material, absorption bands also appear at wave number 769 and 100 and 2100, 200, 100 to 1258 per centimeter, indicating NH vibration and CN vibration. The characteristic peaks of zircon and iron gradually shift with increasing iron content, indicating that the addition of iron can affect the electronic structure of zirconium oxygen in zirconium MOF. This indicates the formation of iron, oxygen, and zircon. And this is SEM image of MCF20 or iron with addition iron 15%, and the material has irregular interground and clustered agglomerated morphology. Bimetallic MOF, iron zircon MOF has a similar morphology with zircon MOF RuIO 66. This is effect of contact time. Contact time in irradiation of UV light. All of the catalysts show catalytic activity in the degradation of MO or methyl orange dye. MO was degraded within 75 minutes with a removal efficiency of more than 98% by the hydrogen peroxide MZF 15 catalyst. And for the material MZF 0, 10 and 20 had removal percentage of 79, 81 and 82% respectively at a contact time of 90 minutes. These different percentage removal value were possible because of the zircon iron mole ratio. The MZF 50 catalyst exhibited the highest iron metal content among the catalyst synthesis material. Iron metal is useful for the formation of hydroxyl radicals. And this is effect of initial concentration. The results show that initial concentration of 30 ppm or milligram per liter, and then 15 milligram per liter and 75 milligram per liter had CT per C0 value close to 0 or equivalent to 100% removal or 90%. However, at 100 milligram per liter, the methyl orange degradation rate decreased drastically, reaching a removal rate of 52%. This is because the methyl orange solution with a higher initial concentration absorbs more UV light than the MO solution with a lower initial concentration. That's inhibiting the excitation of hydroxyl radical and decreasing the degradation rate. And then effect of hydrogen peroxide dose. This increased degradation rate is due to the dissociation of hydrogen peroxide into hydroxyl radicals, which are the major oxidizing agents. At hydrogen peroxide volume of 0 milli, the removal rate was 48%, the smallest degradation rate, and there are no hydroxyl radicals that break down organic dyes, so the process that occurs is only an absorption process without degradation. When the hydrogen peroxide dose from 2.5 milli, the degradation rate decreased slightly. This is caused by competition between the excess hydrogen peroxide in the system and the MO dye to obtain hydroxyl radicals. And this is possible mechanism. The MO degradation process, there are the absorption process or drug reaction and photophantom process, light reaction with UV light irradiation. Hydrogen peroxide reacts with the excited electron to produce the hydroxyl radical, and the iron redox pair Fa3 plus Fa2 plus is converted into hydroxyl radicals and hydroperoxyl radicals. The MOF zircon Fa MOF produce photogenerated electron for Fa3 reduction. The iron side receives photogenerated electron from the conduction band and reacts with hydrogen peroxide to produce hydroxyl radicals. The zircon side receives photogenerated electrons and transfer them to oxygen molecules to form oxygen, thereby increasing the oxidation capacity of these electrons. And last conclusion, the performance of the material as a photocatalyst in the photophantom process showed that the addition of iron improved the MO degradation performance. The results show that the MZF 50 material has degradation efficiency of 98% within 19 minutes at a concentration of 50 milligrams per liter and hydrogen peroxide concentration of 2 mils. Thank you for your attention.
Okay, thank you so much, Miss Miftahul Jannah. Please give applause. We don't have time to discuss. And for Miss Miftahul Jannah, we move to Mr. Yudhistira Madani Putra Siahaan. Please welcome. The slide, please. Okay, times is yours.
Okay, good afternoon, ladies and gentlemen. Let me introduce myself. My name is Yudhistira Madani Putra Siahaan, and today I will present my research topic about comparison of reduction of hydroxylamine hydrochloride, ascorbic acid, and sodium sulfite in analysis of iron with Zn2+ disturbing ion. Iron is the second most abundant metal element on Earth and is crucial in the metabolism of plants, animals, and humans as long as not in excessive amount. Fe2 and Fe3 have significance in various natural science because the bioavailability and metabolism of iron differ between these two states. Both Fe2 and Fe3 play important roles. For example, Fe2 is essential for good health and plants require certain amounts of Fe2 to survive. The determination of iron concentration using UV spectrophotometry has been widely conducted because the process is fast, easy, and has good accuracy. A color solution is required for this analysis, one of which is 1.10 phenanthroline. The analysis of iron concentration is not free from the possibility of interference caused by ions such as Mn2+, Ag+, Zn2+, and Mg2+. In previous research on the determination of iron concentration by comparing two reductions, hydroxylamine hydrochloride, sodium thiosulfite, and ascorbic acid, it was mentioned that the order of the most effective reduction was hydroxylamine hydrochloride, ascorbic acid, and sodium thiosulfite. And to the methodology, this is the tool that I use for my research. Another tools, and this is the materials that I use for my research. Another materials. In research methodology, most of my research methodology are preparing standard solution like this one. The first is preparation of 100 ppm Fe3 standard solution. Most of my research methodology have the same step, but the difference is only at the weight from the Fe3 or Zn2+. The step is the same, weight 0.0724 grams, and then dissolve with aqua de mineral and homogenize at volumetric flash until mark. And this is the same, the difference only on the weight. And the only difference, this is the difference on preparation of 100 ppm 1.10 phenanthroline. In 1.10 phenanthroline need heated 60 degree temperature Celsius and then dissolve with aqua de mineral. And for acetate buffer need add 5 milli acetic acid glacial. And then this is the preparation of maximum wavelength blank solution. The step is at reduction 1.1 milli, and then at 1.5 milli to 1.10 phenanthroline, 1.5 milli acetate buffer, and 5 milli acetone, and then dissolve with aqua de mineral until mark. And then shake and leave for 15 minutes, and measured absorbance with UV spectrophotometry. And for the determination of maximum wavelength, the step is almost same with before, but at Fe3 100 ppm 0.5 milli. And for the determination of optimal reducing agent concentration, the step is same, but at reduction there is a variation of concentration of reducer from 0.2 until 0.6 milli. And then at optimal reducing agent reaction time, the step is almost the same. The difference is on the variation of the waiting time from 0 until 90 minutes. For calibration curve, the difference is on concentration concentration Fe from 0 until 0.5. And for effect of Zn2 on hydroxylamine hydrochloride reduction, there is at Zn2 plus solution with 5 variation concentration from 0.01 until 0.05. And for ascorbic acid reduction, the difference only in variation concentration of Zn2 plus from 0.1 until 0.5. And from sodium sulfite, the Zn2 plus variation concentration is from 0.001 until 0.005 milli. And to result and discussion, the first is determination of maximum wavelength for hydroxylamine hydrochloride reduction. Hydroxylamine hydrochloride maximum wavelength at 510 nanometer with absorbance value of 0.4605. And for sodium sulfite, maximum wavelength same at 510 and absorbance value at 0.343. And for ascorbic acid, maximum wavelength also at 510 nanometer with absorbance value 0.5055. And determination of optimum reducing agent concentration for hydroxylamine hydrochloride, we got concentration optimum at 6 ppm with absorbance value 0.41. For sodium sulfite, concentration optimum at 20 ppm with absorbance value 0.3825. For ascorbic acid, concentration optimum at 6 ppm with 0.17. And next, for determination of optimal reducing agent reaction time for hydroxylamine hydrochloride, the time optimum is at 60 minutes with absorbance value 0.452. And for sodium sulfite, the optimum time is at 60 minutes and 0.511. For ascorbic acid, time optimum at 75 minutes with absorbance value 0.604. And then determination of Fe2 phenanthroline calibration curve. In this curve calibration, I got linear equation and R square at 0.9964. And for sodium sulfite curve calibration, R square is same at 0.9964. For ascorbic acid, also same, R square at 0.9964. And The effect of ZN2 on hydroxylamine hydrochloride reduction. In the reduction hydroxylamine hydrochloride, ZN2 plus ions interferes with the analysis of Fe2 phenanthroline by reducing the absorbance value along with increasing ZN2 plus ion concentration, starting at a concentration of 0.1 ppm with percent recovery of 92.1%. And effect of ZN2 on sodium sulfate reduction. ZN2 plus ions interferes analysis of Fe2 phenanthroline by increasing the absorbance value along with increasing ZN2 plus ion concentration, starting into inference with a concentration of 0 ppm with a percent recovery of 64.99%, not disturbing at concentration 0.003 ppm with a percent recovery of 95.64%, and disturbed again at a concentration of 0.004 ppm with a recovery percentage of 111.99%, because the recovery limit was in the 95% until 105% range. And effect of ZN2 on ascorbic acid reduction. ZN2 plus ions interferes with the analysis of Fe2 phenanthroline by increasing the absorbance value along with increasing ZN2 plus ion concentration, starting at a concentration of 3 ppm with a percent recovery of 92.15%, because the recovery absolute limit is from 95 until 105%. The ZN2 plus ion succeeded in disrupting the Fe2 phenanthroline complex by influencing the absorbance value to increase and decrease, and can be proven by the voltaic series. In the voltaic series, the more left atom is more reactive than on the right. In this voltaic series, Zn is more left than Fe, so Zn can interfere on iron analysis. Conclusion and recommendation. Zn2 plus can affect the Fe2 phenanthroline complex as evidenced by a decrease in the absorbance value for the reduction hydroxylamine hydrochloride, an increase in the absorbance value for the reduction sodium sulfite and ascorbic acid as the concentration of Zn2 plus is added. Under the optimum condition for its reducing agent, hydroxylamine hydrochloride is said to be more stable and more efficient for reducing Fe3 plus following by sodium sulfite and ascorbic acid. Recommendation: future research can be tested using other interfering ions such as Cu2 plus, Pb2 plus, Ne2 plus, and another to find out whether the results obtained are the same or whether there are significant difference if other interfering ions are used. Okay, thank you.
Okay, thank you so much. Please give applause to Mr. Yudhistira. We have 3 minutes to Q&A. Do you have a question? Yes, please.
Yes, thank you, Ms. Moderator, and thank you for the very nice presentation. So, this is not my my area of expertise, so I don't know if this question is too easy or else, but so my question is about the recovery limit that you say that this is between 95% to 105%. So what is the meaning of a recovery percentage more than 100%? Thank you.
Okay.
Not working. Okay. I think no. The next slide. The next slide. 105. 105.
Okay, maybe I will answer. So the mean for percent recovery limit 95 from 95 to 105% is the standard. The use from percent recovery can accept it. This is standard from the reference that I got, and if the percent recovery is more than 105, it means the product that we got is we got more product than the standard should be. So if the product is over the standard that used, it concludes that this product is not good for the research because not apa? Because because the product is over.
Okay, so do you mean the product is more than the standard concentration,
yes.
right? Okay, is it clear? Okay, we still have a time. Haikal, 2 minutes. Is there any question? Okay, please.
Okay, thank you for the time. My name is Ruzain Rafi Sukmaputra. I'm a student from Department of Chemistry in ITS Surabaya. My question is, you are say the addition of disturbing ion zinc, right? Zn2 plus. This is my new field. This is something new for me. But how does the zinc ion can interference with the reduction of iron itself? What did it do, or what does the zinc do in the reduction process? Thank you.
Okay, you can answer.
Okay. Maybe if the Zn2 plus is affect on with, like example, if there is no ion disturbing, the reaction could be more fast and more efficient. But if we put ion disturbing such as Zn2 plus, and then the reaction can be more take time and not effective as if not there is not ion disturbing. In industry affect in industry.
I mean, how does the zinc itself is affecting in iron reduction? Is it because the zinc itself will be reduct, or something else that happened during that process of reduction with your reduction agent?
Maybe the reaction is still can success, but if we put some ion disturbing, like I said before, the reaction time will be more take time, and it can affect on percent recovery, and Zn2 plus can disrupt by increasing the absorbance or decreasing the absorbance value, depends on the strong or the low the reductor.
Okay. Okay, times is up. Thank you so much for Mr. Yudhistira. Please give applause. Okay, we have one more presenter, Mr. Hendro Juwono. The slide, please. Okay.
We are still waiting since it was not downloading.
Okay.
So
we will wait.
Maybe Professor Hendro could sit down first. Just we are waiting for this one for a moment.
Okay. We still wait.
Yeah, we're still waiting, and it'll take like 2 minutes.
2 minutes.
2 minutes again. Okay.
Okay, it is already there.
Okay. Okay.
Okay, thank you.
For Mr. Hendro Juwono, times is yours.
Thank you, Bu Kartika. Good afternoon, everybody. Let me introduce myself. My name is Hendro Juwono. This is my project at 2024. The effect of polyethylene terephthalate addition to crude palm oil, CPO, catalytic pyrolysis, to produce alternative hydrocarbons. My name is Hendro Juwono. It's with Anas Imron and Yuli Kusumawati. Next. Introduction. The aim of this research is what the effect of addition plastic waste from polyethylene terephthalate to biomass, crude palm oil, and via catalytic pyrolysis to produce alternative hydrocarbon. So the problem is we have a lot of plastic waste, bottle plastic waste from polyethylene terephthalate, and we have a lot of waste cooking oil from crude palm oil, and if we uncontrol of bottle plastic waste of polyethylene terephthalate, so make a serious problem from environment, and we have a solution to converting plastic polyethylene terephthalate waste into fuel using a cracking method. And we also have a method to change the waste coconut palm oil to biodiesel, and we have looking for the alternative energy and apply it gasoline engine. Our research is effect of polyethylene terephthalate addition to crude palm oil through catalytic pyrolysis and produce alternative hydrocarbon. In experimental, first we synthesize of the catalyst. Catalyst, we have usual catalyst like MCM41, or we doping with nickel, and the characterization of the catalyst, we use nitrogen absorption desorptions. We didn't use FTR pyridine, but we use temperature program desorption to analyze acidity of the catalyst, and we have analyzed with X-ray diffraction. Hydrocarbon fuel production by catalytic cracking, to know that the component of hydrogen fuels production, the characterization of hydrocarbon fraction with gas chromatography MS. And we also analyze the product of hydrocarbon fraction with color value, physical properties, and reset octane number. Okay, this is my tools, my experimental method. First, we took the sample from to the reactor chamber, and we flow the nitrogen gas to the reactor until we have 2 bar pressure. So the nitrogen gas and hydrogen gas, it's similar function, and we heat the reactor until 450 degrees Celsius. So the gas will be through the temperature of catalyst, and we have a condensed product to the tanker. And result and discussion from the characterization of catalyst for aluminum MCM41 and nickel aluminum MCM41. We have that the XRD diffractogram is different. So nickel have loaded to the MCM41. And from nitrogen absorption desorption characterization, we have different surface area, pore volume, and pore diameter. From temperature program desorption, we have more acidity properties, nickel aluminum MCM41. So the acidity from aluminum MCM41 and nickel aluminum MCM41 more acid nickel aluminum MCM41. So the acidity will be more convenience to crack the CPO PET sample. So from gas chromatograph, from this reactor, we have more different yield by sample CPO PET mass ratio. We also have a fraction of hydrocarbon. The goal in my research is the fraction of C until C7 until C12. So the addition of PET didn't disadvantage to make aromatic hydrocarbon. We have optimization of addition plastic polyethylene sulfate to produce hydrocarbon C7 and C until C12. It's have a round number. There is no from until 105 round number. It's mean I don't know. Maybe it's additive from biogasoline. Okay, thank you.
Okay, thank you so much for Mr. Hendro Chuano. We have 5 minutes to Q&A. Is there any question? Do you have a question? No? Okay. Okay, I will ask you. So, do you use a PET to produce biogasoline, right? What is different with the other polymers?
why I use polyethylene terephthalate, PET, because my hypothesis, PET more aromatic function. So if I use PET, we will have gasoline with more aromatic function.
Structure. Oh, I see. Okay. So, for this data, for your future work, what do you want to do next?
Yeah, because aromatic compound from the gasoline, it's make reset octane number more high. So if we have more aromatic function from in the gasoline, we have high round number in gasoline.
Okay.
We have still polystyrene. Styrene is aromatic function.
Yes.
And polyethylene have aromatic function too, but polystyrene and polyethylene terephthalate have a different melt point.
Okay. So it is possible for us to produce biogasoline using this method.
Yeah.
For the next.
Yeah, for the next, but we have more catalyst.
Okay. So we still need more study for
we need more development of the catalyst.
Okay, thank you. Okay. 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 Time is up. Thank you so much for Mr. Hendro. And this is the end of the second parallel session. So thank you so much for your kind attention. And for next, okay, we have a coffee break, and please stay in here room to have a closing ceremonial. So thank you so much once again, and see you in the next ISOC in 2026. Thank you so much.
Nara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to 4 business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Mas Murni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Mas Murni is providing the first-rate after-sales service in its field of business. all aligned with PT Fajar Masmurni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
ketemunya para ilmuwan, walaupun ada yang offline, ada yang online, sehingga acara ini hybrid. Tetapi secara garis besar kita dapat mendapat pencerahan, ilmu-ilmu baru.
Audio Jungle.
So I'm from the Advanced Membrane Technology Research Center. I'm at University Technology Malaysia Sunda.
So, like I showed just now, we have the operating temperature of the PMFC up to 120 degrees C. So we try to find out or to determine whether our membrane is capable to withstand with this temperature, right? But in terms of the gas evolved, we never try with this TGA approach in order to determine what type of gas evolved during the operation.
Catalytic conversions. Before we start this process, also prepared previously for the catalyst. In this research, we used for 0.08 in molar ratio alkaline catalyst, namely potassium hydroxide.
My name is Heriberto Diaz. I studied in my bachelor and master's of science in Mexico.
Assalamualaikum warahmatullahi wabarakatuh. Terima kasih semua. Alhamdulillah acara ISOC saat ini lancar dengan baik dan mudah-mudahan menghasilkan ilmu-ilmu yang bermanfaat dan dapat dipublikasikan jurnal yang lebih baik atau posting yang lebih baik. Mudah-mudahan pada kesempatan yang akan datang dapat diperbaiki untuk memperbaiki mutu dari penampilan dan kualitas dari acara ini. Terima kasih atas bantuan para pimpinan ITS, kemudian Dikti yang memberikan pendanaan juga, kemudian departemen yang memberi fasilitas dan fakultas, dan teman-teman semua. Saya mengaturkan terima kasih yang sebesar-besarnya sampai terselenggaranya ISOC ini berjalan lancar dan tertib. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
process of bachelor degree. In the pandemic, learning is generally carried out by Zoom. Even though it is online, various learning methods in delivering courses can still be done, such as providing one-way material, discussions, group discussions, and doing practice questions. Delivery of lecture material is carried out using either a PowerPoint.
Gitu ya. Jadi kalau kita makan lemak ya, misalkan gajih gitu ya.
Persatuan volume ikan-ikan.
Explaining from textbook sources.
Konsentrasi A dikali AR-nya, tetapi ini berbeda karena ada yang mengurangi sejumlah KR absorpsi tadi ya.
As well as adding other sources that can enrich the subject. For example, in the subject of atomic and molecular structure, students are shown the website chemtube.com, which visualize several types of molecular orbital to make students become more aware of symmetry that are difficult to imagine. In the subject Modern Physics, the lecturer also introduced students to use EduGame in gamelab.mid.edu to help students understand about the relativity concept.
Nah, warnanya kalau kita perhatikan itu kayak ke arah.
The subject structures, properties, and reactivity of inorganic compounds. Lecturer asks students to make the molecule model using plasticine when explained about the molecule symmetry concept. Lecturer also developed the web from the medium to deliver the subject content as performed in the subject chemometric. Some subjects also add the external exposure to introduce students the subject application. For example, in the subject marine chemistry, students go to the sea to see various marine species. Then they discuss the relation to the subject. This activity was done in 2019 before COVID pandemic. In the pandemic, the external exposure is replaced by the virtual external exposure. In the subject chemistry membrane, the lecturer invites the industry practitioner to sharing about the problem of membrane application in industry, and the students are invited to discuss the solution. In the subject research methodology, students are required to be more active in exploring chemistry literatures and writing it down in the form of manuscripts, oral presentation, and posters. Guidance on how to search literatures is done in practice, directly by showing several websites related to searches on chemistry. For subjects that require students to have the ability to calculate, exercises are carried out and discussed carefully. Implementation of assessments are carried out in various ways, such as conducting tests via My ITS Classroom and supervision using Zoom, or giving other tasks that can increase learning outcomes in the form of skills. For example, subjects biochemistry and foodstuff chemistry have assignments that are required to be submitted through the TikTok app. Subject chemical literature gives out assignments of video presentation, example, video, and poster. During this pandemic period, practicum is carried out either with demonstration in the laboratory with the help of lab assistants, or some practicum are developed with an online module. The following is a video footage of the Chemistry 2 Basic Technique Laboratory. Measurement of density.
Perkembangan pengukuran densitas zat padat dan zat cair.
Solution.
Mari kita lakukan percobaan 3.
Thermodynamics. Calorimeter bomb. Binary solution. Freezing point.
Kita akan melakukan praktikum termodinamika yang membuat pasang dengan menggunakan metode
chemical dynamics. H2O2 decomposition. Acetone iodoform reaction. Synthesis organic reaction practicum. Styrene polymerization. Welcome to the Chemistry Department Faculty of Science and Data Analytics, Institut Teknologi 10 November, Surabaya. The Chemistry Department of ITS has plenty building facilities for students to use. For instance, classrooms with capacity of 40 to 50 persons, each with LCD projector, AC, and Wi-Fi. Trial rooms for final project presentation and thesis. discussion space at the corridor. The chemistry office for administration is placed on the second floor. There is a waiting room, office area, discussion room for lecturer rooms, and prayer room. There is also a small library on the fourth floor. Due to the pandemic, during this past year, most learning has been conducted online, generally via Zoom. ITS has Moodle-based learning platform called My ITS Classroom. In My ITS Classroom, students and lecturers can find out which courses could be taken in a particular semester. There are also several activities that can be carried out. For instance, uploading files, both lecture files and videos, managing face-to-face meetings, doing assignments, arranging exams. There are 6 laboratories consisting of 1 educational laboratory at the Fundamental Chemistry Laboratory and 5 research laboratories that can support the students' research and learning activities. The other 5 laboratories, the research laboratories, consisting of the Instrumental and Chemical Analysis Method Laboratory, the Microbiochemistry Laboratory, Chemistry and Energy Laboratory. The Natural Product and Chemical Synthesis Laboratory. Molecular Geochemistry Laboratory. Learning process of master degree. The teaching methodology in the MOC is conducted by various methods. The conventional explanation by the lecturer followed by the class discussion. The courses that adapt this method are thermal analysis.
Di thermal analysis nanti kita akan belajar tentang yang pertama nanti kita ada TGA seperti ini, sebenarnya gambarnya, kemudian ada TTA seperti yang di atas ini, kemudian yang di tengah ini adalah DSD, yang ini TFA dan yang bawah di sini adalah DSD.
Research methodology.
Lebih spesifik ya dibandingkan manfaat, karena ada yang tidak tahu juga.
Membrane synthesis.
Yang paling mudah dibuat itu menggunakan inversi fase ini. Metode-metode yang lain ada, nanti kita akan bahas juga metode-metode yang lain, meskipun metode yang lain.
Natural products chemistry.
Gamanya yang dekat A ini alfa, yang di puncak atas itu beta di bawah, gamma di sini. Jadi gamma-gamma, dua gamanya. Dimetil, tadi siapa yang nanya ada dimetil di hidroksi, ini dua metil.
Quantum chemistry. For quantum chemistry, students are required to have a deep concept understanding and ability to derive several equations. The video show that lecturer was direct the students to derive several equations and solve several problems. The study based on the recent article in the journal that has a relationship with the topic. The article-based study as an additional source explained by the lecturers. Discussion topic or presented by the students to develop concept and build the knowledge. Here is the courses that adapt this method. Structure and analysis of surface. The recent research on the application of structure and analysis of surface is studied based on the recent publication. For example, the study of scanning electron microscopy to identify a non-edible oil seed as energy cores. Molecular reaction dynamics. In addition, the explanation based on article-based study, the lecturer also gave the assignment for students to study the article.
Telah disajikan 3 artikel mengenai spektroskopi Doppler, yaitu mengenai aplikasi terkini untuk mengamati perkembangan
porous material.
Warna tekstil dihasilkan banyak oleh industri, diantara industri batik, industri tekstil, industri poluan tekstil, dan industri bagian batik, bahwa dimodifikasi dengan reos, kemudian dilakukan
membrane synthesis.
Dimulai dari introduction overview, yaitu teknologi membran yang muncul sebagai teknologi inti di bidang pemisahan, dan juga diterapkan secara luas di berbagai bidang, terutama untuk pengolahan air, limbah, industri, farmasi, makanan, bioteknologi,
material. Di antara berbagai metode yang ada, metode kompresipitasi merupakan metode yang paling sering digunakan.
Yang balik lagi ke ini ya, awal kita menemukan masalah ya, jadi tadi.
Namun penjelasan terkait interaksi yang terjadi antara nikel yang didoping pada ZNO terhadap pewarna tersebut belum dijelaskan secara detail. Oleh karena itu, pada penelitian ini kami menyampaikan
In year 1973, with General Importer as core of its business, PT Fajar Mas Murni has marked the beginning of its glorious journey. In its first office in Menara Hijau, PT Fajar Mas Murni has morphing into a trading company that actively contributing to Indonesia's national development up to this very moment. It has also becoming a preferred and trusted company for its business partners. On the 11th of May 1978, PT Fajar Mas Murni has accepted the challenge to enter the global market by establishing international partnerships and represent several prominent brands from numerous countries. To assert the transformation and strengthen the image as a dynamic, competitive, and always keep abreast of technological advances company, on 2021, PT Fajar Mas Murni has rebranded its logo. Becoming an exclusive distributor for several prominent brands, PT Fajar Mas Murni is confident that it can give a high standard support to 4 business groups: industrial technologies equipment, construction and mining equipment, laboratory and inspection equipment, rotating and process equipment. By establishing branch offices in major cities in Indonesia, PT Fajar Mas Murni is ensuring that the service quality align with its market expansion. PT Fajar Mas Murni is committed to establish good relationship with business partners. With complete warehouse and workshop facilities and supported by skilled and professional human resources, PT Fajar Mas Murni is providing the first-rate after-sales service in its field of business. All aligned with PT Fajar Mas Murni vision and mission commitment to provide the excellent services by implementing the good management standard on quality, health, safety, and environment.
Department Faculty of Science and Data.
Okay, we see finally that the room has been filled enough, so may I have your attention, please, in the front. The honorable guests, our keynote speakers, and our invited speakers, and all of the participants, ladies and gentlemen, welcome to the closing ceremony of the 6th International Seminar on Chemistry 2024. It's been 2 long days, 2 consecutive days full of presentations, full of questions, and full of discussions. And finally, we are coming to an end to basically close the event itself. Me personally and the committee itself wish you have a comfortable conference that you guys held today. Hope you guys also enjoy Bali after this. And we are gonna waiting for you and for your upcoming research also. There are some few agendas before we are formally closing this event itself. The first one is remarks coming from the Indonesian Chemistry Associations or HKI, Himpunan Kimia Indonesia, and the speech itself is going to be brought by Mr. Wahyu Prasetya Utomo. For Mr. Wahyu, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Actually, it is an honor for me to represent the Indonesian Chemical Society or Himpunan Kimia Indonesia to be presented or introduced in this international seminar on chemistry. Even though most of us are chemists or working in the field that related to chemistry, maybe in Indonesian community itself, we are not aware of that we have an association which compiled all of the chemists and its related partner in an association which is Himpunan Kimia Indonesia. So therefore, I would like to introduce the Himpunan Kimia Indonesia. I'm now as the chair or elected chair of the Himpunan Kimia Indonesia or Indonesian Chemical Society in the East Java chapter. So basically, the Indonesian Chemical Society or Himpunan Kimia Indonesia is a non-profit organization which aims to nurture the general advancement of chemical science in Indonesia for the welfare of Indonesian citizens. The membership is not only the researchers or scientists from the academia backgrounds, but also the practitioners from the industrials and the business sector. For the one who would like to know more about the Himpunan Kimia Indonesia, especially the students and everyone who didn't know about this association yet, you can visit our website, official website in the hka.org.id. And we welcome you to be a part of Himpunan Kimia Indonesia. The students, please be confident. If you want to join us, it will increase your opportunity to collaborate with all of the partners in chemistry and related field. That's all what I want to say. Thank you for the opportunity to be here, and thank you for your attention. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you so much for Mr. Wahyu for the remarks and the speeches introducing Indonesian Chemical Associations or Himpunan Kimia Indonesia. Next up in our list is actually an awarding sessions is presented to all the best speakers that is especially in parallel room that give significant and also give tremendous effort in their presentations, and we could say that their result they can be the best. So we awarded them to be a best presenter in this conference itself. Okay, change of plans. Wait a second. Okay, we're gonna go into the awarding sessions first. Can the operator show us the slides for the best presenter? And we have 5 oral presenter and 1 poster. So I'm still waiting. So the first best presenter I am so sorry for these inconveniences. Okay, so sorry for the inconvenience and technical issues. We are moving on to the next sessions. Also, another remarks coming from our partner or like our collaborator for this conferences itself, which is OWSD, an Organizations for Women in Science. That is actually one of our invited speakers and one of our teachers here in ITS is actually a head of this organization itself. So without further ado, I give it a time for the remarks from the OWSD to Mrs. Sri Fatmawati, PhD. For Mrs. Sri Fatmawati, the time is yours.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, first of all, I would like to express my sincere gratitude to ISOC, International Seminar on Chemistry, keynote speaker, distinguished speaker, and all of the guest speaker from around the world. So today I would like to give you briefly about one of the organization in Indonesia, which is the host institution is Institut Teknologi 10 November, and this is very this is very good for us in OS because ISOC itself is part in the journey of OS. We called it OWSE SOs, yeah. So next maybe. So OS has 54 countries, and this is a non-profit organization under the World Academy of Sciences under the UNESCO. And right now, actually, we have more than 57 countries around the world, and including in Indonesia. So next. OS itself, we established in 2017, and based on the decree of Chancellor of ITS at that time, we have finally established the OS Indonesia National Chapter, and 2018, the next. Yeah, as you can see here, this is the first time OS have the first Women in Zion Congress in Indonesia under ISOC. So we collaborate with ISOC. At that time, 2018, I believe in Sheraton Hotel in Surabaya. And we also have a partner with the L'Oréal UNESCO for Women in Science. And for your information, this is, I'm thrilled and I'm very proud that OS Indonesia is under the ITS. And of course, this can be happen because we have a more support, not only for women, but also for men. So would you please to give the applause for our Dean, Professor Hamzah Fansuri. Yeah. And also for the head of the Department of Chemistry, Professor Freddy Kurniawan. So both of them give us the support. And then next. So actually, this is the logo of the OS Indonesia National Chapter. So we have the women who carry atom, the wings, Garuda wing, and the lotus, and finally the like. So this is the logo. How the women in science in Indonesia would like to contribute to the development of women in science in Indonesia. So next. So this is our objective right now. We have more collaboration not only with the organization in Indonesia like a Ministry of Research and Education. We also have the Ministry of Women Empowerment and Ministry of Social and also Ministry of what is it? Bappenas, yeah. And then next. So this is the structure, and I'm the chair and the president of Indonesia National Chapter. Next. And yeah, this is the 2 months ago. So now we have more than 200 members across Indonesia from 22 provinces in Indonesia, and we have 17 women professors, and more than 80 doctoral degree from the members from 93 institutions. So we have 88 universities, and other is like the industry also. Next. And this is the growth of our member until now. Since 2017 is increased significantly. Next. And yeah, this is a glimpse of activities. Maybe next, yeah, just click and click. So maybe you can see how we collaborate with some seminar, congress, not only with ISOC, but also others. So we also have a charity workshop, OS Goes to School training for students. And next. Yeah, this is during pandemic. Yeah, we have a lot of webinars. Next, together with the Ministry of Education, Research, and also others. Next, maybe. Yeah, we held some annual meeting, congress, etc. And finally, yeah, this is the talk series. Every month, we present one talk series with the member of OS across the Indonesia. Next activities, and this is last year. Yeah, still have a webinar, annual meeting, etc. And next, and yeah, and for last year, we finally have one program on behalf of the University of Brawijaya in Malang, together with the Institut Teknologi 10 November, ITS, and University of Hasanuddin, and University of Pajajaran Bandung, and University of Lambung Mangkurat, Kalimantan. We finally decided to have a collaboration under the OS ICR, Inclusive Collaborative Research. So we try to have the consortium, the collaboration, research among OS members. So this is the platform for everyone who want to develop together with the women in science in Indonesia. And I believe that ISOC still the best partner, yeah, because since we are established in 2018, ISOC have the lot of activities, as you can see. Yeah, so please join us if you have any questions. So this is welcome for everybody, not only for women, but also for men, because we have 20% men in science. So for your information, now if we have like the women in science, and UNESCO now launched one of the program, namely men who support women. Means that we know that based on the data from UNESCO, until now, under 30% of scientists in the world, yeah, is women. So more than that. And I would like to thank you so much for the ISOC, because right now we have 5 keynote speakers, which is one is Professor Fahima, yeah, and this is also for all of you guys. For let's say, for example, panel, we call it men panel only. So if you have any invitation for giving a talk or series or webinar, etc., if there is no women in that panel, mean you already destroy the one of the UN regulation. That if you believe that you are part of science, so you need to support women in science. Thank you.
Thank you so much for Ms. Rifat Mawati, for the head of Organizations of Women in Science in Developing World. Right now, we are finally moving on to the awarding session. So once again, these are, we could say, the best presenter and the best poster coming from the parallel session that is happening in the past 2 days. And I will announce in the totally random order. So the best presenter for, we have 5 best presenter and 1 best poster. And the first best presenter is Abu Hurairah. Please give an applause. And the second is Mazidatul Akmam. Please give us all applause. The third best presenter is Miss Utari Zulfiani. And for the fourth best presenter is Mr. Muhammad Fadillah. And the last best oral presenter is Nurhaida Muhammad Khas. And for the last one is actually the best poster that already exhibit in the back part later on, not later on, but in this morning. So the best poster goes to Miss Lilis Fitriana. And to award these people that won the best presenter and the best poster, we invite the winner, which I think Mazidatul Akmam is the person here. Okay, no. Miss Utari Zulfiani, please come to the front to receive the token of appreciations. Muhammad Fadlillah, okay, please also come to the front. And for the first 2, we invite Mr. Trianda Gunawan to award these token of appreciation. For Ms. Muhammad Fadillah, please also come front. Okay, for the next one, Mr. Fadilah, you can. Oh yeah, the other one, Mr. Fadilah. Okay. Oh wait for a second. Okay. Please change places. Okay, thank you so much for Mr. Trianda, and thank you so much for the winners. You guys could go back to your places. What another now we call upon is there Mrs. Nurhaida is here? Okay, I think not. Miss Lilis Fitriana, also not here. Miss Lilis Fitriana, okay. I think it's not here, and we conclude the awarding sessions in this case. Once again, congratulations to all of the winners. We are hoping that, thank you so much for the tremendous presentations that you guys give for the past 2 days. Right now, we are moving on to the closing remarks, and the last closing remarks will be delivered by the chairman of the 6th International Seminar on Chemistry 2024, which is Mr. Trianda Gunawan. For Mr. Trianda, the time is yours.
Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good evening, everyone. I'm finally can smile now after the tired 2 days, and finally my job is over basically today. So, okay, once again, thank you for everyone who are still stay here, still connected, and the first of all, I would like to thanks to our collaboration, Himpunan Kimia Indonesia, which is play a very vital roles in recruiting local participants for these seminars, and as well as the OSD or OS for actively looking for the international participants, as well as the sponsors. Here we have PT IKA, FMM, and the others, my apology, for supporting invaluable support for us and contributing to the ISOCs, as well as I would like to thanks to our keynotes, Prof. Yun Hao Eng, Prof. Mark Buntain, Prof. Fahimah Marta, Prof. Sensei Shigeru Ukada, and the last but not the least is Dr. Aditya from Main IT. I would like also express our gratitude to our invited speakers who are accepting our invitation and coming to Bali. Hopefully all of you have already enjoyed Bali, and I'm very sorry if we have anything displeased you during your stay here. And last but not least, we have learned a lot of things during these 2 days. Started with the Prof. Shigeru with the organic chemistry, and followed by the Prof. Yun Hao with the hydrogen produce, and the last keynote is from Dr. Aditya, who talks about the minerals, the role of chemistry from the lab to the industry. And this second day, the last day, we have learned about the UV-Vis and the laser technique to produce a nanomaterial for Mark Buntain, as well as the complex compound to cure the cancer from Prof. Fahimah Marta. Hopefully all of you enjoy the seminar, have a fruitful discussion, as well as maybe already share some connection and share some future collaboration between us. And to close and to wrap this seminar, I would like to present you, we would like to present you the, not a recap, a brief recap of our last 2 days activity. Please enjoy. Okay, so I believe it is the last. Thank you, thank you. It's really a pleasure hosting these seminars, and I would like also to thank for all of the task force team, and as well as the strong team. We have a WhatsApp group called Strong Team for the committee who do the rusting. I'm very thank you for all of your helps, and as mentioned in the last video, we will come you to the next ISOCs, which is the 7th ISOCs International Seminar on Chemistry, will be held on 2026 on July. And for those chances, I would like to invite the next chairman for the ISOCs. Dr. Wahyu, please come to the front. Now it's about time for me to pass this sacred microphones to the next leader of the ISOCs. Please.
Thank you very much, Pak Trianda, and thank you, everyone. He can smell now, but I'm start to thinking on how I should do and what I need to do. But I believe that with all of your support and the collaborations that we have initiated from now and from the previous ISOC, I believe that the ISOC in 2026 will be better and better. Thank you. Hopefully we can still maintain our good relationship, our good collaboration and cooperation from keynote speakers, invited speakers, and also from all of the presenters, not only from Indonesia, but also from overseas to join us again, and we can gather together as a reunion maybe, or just a common place to share knowledge and science. I think maybe later on you will still meet me again with all of my emails, just to publish my events. Maybe you, starting from now, you have been, oh, this guy again, but be sure maybe you will get my terror again. Thank you very much for everyone. Thank you very much for the chair. Thank you very much for the Department of ETS, of Chemistry ETS. And see you. Hey, have I told you where we should do our next event? Not yet, right? Today we do it in Bali. We know that Bali is a very famous and popular tourism destination. And for the next ISOC, the ISOC will be held in Lombok. If you don't know the Lombok yet, Lombok is also a emerging tourism destinations in Indonesia. It's really close to Bali. So when you come to Lombok, definitely you will come to Bali. So you can enjoy both the paradise islands of Indonesia. Thank you very much, and we welcome you on ISOC 2027. Thank you very much.
Thank you so much, Mr. Trianda, and thank you so much, our future chairman, Mr. Wahyu. And yeah, we could see, I'm almost tearing up actually, since it was like a little bit emotional, especially coming from Mr. Wahyu's speech. But nonetheless, yes, the next ISOC is going to be held on the island next door, which is in Lombok. It's not too far away, once again, coming from this island, which is Bali. And we are coming, the event is finally formally closed, and we are coming to the end of the closing session itself also. Once again, we as a committee, thank you so much for your attendance and for coming into this island, for coming into our conferences. We hope to see you in the next editions of International Seminar on Chemistry. My name is Muhammad Haikal Fazet, and I am signing out as an MC. Thank you so much, and thank you, and see you guys next year. And after this, we're going to do a photo session. So, yeah, we're going to do a photo session. So please do conduct, maybe Mr. Wahyu, we're going to help me conduct the event itself. And yeah, once again, thank you so much, and see you in Lombok. Because of space limitations, later on, after this. Because of the space limitations, so we're gonna conduct the photo sessions in where you are currently right now. So okay, so please, if you guys have any spaces to your you have any spaces, please get closer to the center of please go to the center of the room itself. That's for Mr. Danang, Mr. Arif, and Miss Fatma. Probably can sit here or sit here. There are still some empty spaces. Or maybe in here. Oh my God. Okay, we're gonna conduct this photo in 1, 2, 3. Once again, 1, 2, 3. And 1, 2, 3. Okay, we're gonna use another phone. Is it better? The white one? Okay, we're gonna conduct another photo sessions. We're gonna conduct another photo sessions in 1, 2, 3. Another pose, 1, 2, 3. Another pose, 1, 2, 3. Okay. Downstairs? All present? Downstairs? Okay, another announcement. We're gonna conduct another photo sessions downstairs. So just another announcement, maybe we could get another photo again downstairs, so all people in this room could move downstairs, so we're gonna take another photo downstairs.